Good morning, Professor Srinivas Chakravarti. I am from Malik.
I'm having a hard time understanding. I think there is some noise issue on your side. Too much static noise here. I'm sorry, I can't. I'm having a hard time. Can you hear me?
Good morning, sir. Good morning. Professor Reddy, good morning. There are some disturbances. Yes, in your mic or...
You know, I'm having a problem. I can see you. Can you see me? I'm having a problem getting your voice, but I can see you. Can you hear me?
There are some technical problems, sir.
Okay. So do you want me to log out and log in, or you're going to fix it on your side?
I am not hearing your voice.
Your voice is not audible, sir.
You want to see my file? Let me share my file and see if you can see it. I can't hear you at all. It's really noisy in the background. Okay, let me log in again. Okay, just let me get back at you. Let me log in.
there is one 3 minutes only. It is a small message by the former Vice Chancellor of Nagpur University, Professor S.P. Gane. So he will just say some message on this morning. So now I request to play Gane's video recording. Only it is 24 minutes. After that, I will hand over the
share చేయరా
Okay, we will display in the afternoon, no problem. We will Mayor Malik is the chairperson for today's morning session. So now I request the organizing secretary to read the.
Very good morning to all the participants.
Yeah, good morning. Good morning.
Today in our first session we are having chairperson as S.P. Malik sir. I'm happy to introduce Dr. S.P. Malik sir. He is presently working as a professor and head Department of Statistics, Delhi University, Rohtak. His field of research specialization are reliability theory, sampling, and applied statistics. He has PhD research field of real analysis, measure theory, optimization techniques, complex analysis, reliability theory, and stochastic models. He has published 3 books in the field of real and complex analysis and published 191 research papers in this field. He has supervised 37 PhD and 28 MPhil students in the subject of physics. He has invited for various academic institutions to deliver invited talks and to present the research papers in conferences, seminars, which includes abroad USA, UK, Singapore, Germany, Hong Kong, and Nepal. He is a reviewer of various journals, specifically for the journals in the areas of reliability, operations research, and statistics. Professor Malik has been a life member of various academic professional bodies. He is the founder, president of the Indian Association of Reliability and Statistics, IARS, and also chief editor of the UGC listed journal IJSRC, being published by IARS. He has worked as elected member of the section of mathematical statistics of ISSA. He has been associated with several universities in India as an outside expert in board of studies and academic council. He also organized various academic activities in form of workshops, seminars, conferences, national and international level. He has been appointed as UGC member of advisory committee for staff. Recently, he completed UGC MRP on reliability modeling of the system. He is also working as a coordinator for the UGC staff. I'm happy to introduce the
Hello?
Yes, thank you very much, Professor Reddy, for giving me a chance to interact with the world-renowned professors who are today going to give you some interesting lectures in this conference. So I'm very thankful to all of you. So I have been given the responsibility to air this session in which 3 talks will be delivered by the renowned professor. In this way, we have the first speaker, Professor Srinivas Chakravarti. I have few words about him, although he does not require any much introduction. He is a well-known professor, particularly in the field of engineering and management. So, but it is my responsibility to introduce Professor Chakravarti with our audience. So, few words about him. Professor Srinivas Chakravarti is currently working in the Department of Industrial and Manufacturing Engineering and Mathematics at Kettering University, Flint, Michigan. Srinivas Chakravarti research interests are in the area of algorithmic probability, quantity, inventory simulation. He has published more than 120 research papers in the journals of good repute and made more than 100 presentations at the national and international conferences. He organized the first international conference on MAMS in stochastic models in 1995 held in Flint. His recognitions and awards include Distinguished Faculty Award in the year 2019, honored by the Examination of India for contributing to the field and the society. Rhodes Professor, Kettering University, Distinguished Research Award, Kettering University, JMI Alumni Outstanding Teaching Award, JMI Outstanding Research Award, JMI Alumni Outstanding. So we can say that he is the recipient of various awards, and definitely Professor Chakravarti is a well-known academician and administrator. So his professional activities include serving as area editor for the Journal of Simulation Modeling Theory and Practice, associate editor for the journal IAPQR Transactions, Indian Association for Productivity, Quality and Reliability. He is advisory board member for several other journals, international conference, reviewer for many professional journals. So, although we have few words about him, but he is a well-known, renowned professor of the world. So I request him kindly to deliver the talk. He has requested some discussion on quiz and services. So I request Srinivas kindly to highlight the situations or the views or the findings in the area of quiz and services. So Professor Srinivas Chakravarti.
Oh, thank you very much. Can you all hear me?
Yes. Absolutely.
Okay. Thank you very much, Professor Malik. I really appreciate your kind words. It's really an honor for me to be making a presentation. In fact, I should also thank Professor Rajshekar Reddy for inviting me. And so I really look forward to having some productive conversation. And without any further ado, I'm going to start presenting. And now what I would like to do is, if you don't mind, I'm going to cut my video so that I can sort of look at the other screen, because if I'm going to look at this screen, I'll see how it goes, okay? Once again, I thank everybody for giving me an opportunity. And now, without further ado, I'm going to talk about the concept, queues and services. Again, this is going to be a more general talk, because I know there are quite a few people who are probably want to get into this area. And secondly, as you know, there's no point in talking about too much technical details in a 45-minute presentation or so. And because of that, I decided to do the following. Okay, basically, I'm just going to give you an overall picture and then take some couple of illustrative models. Okay, and I would like to first of all, it's really my sincere, as I said before, really a great honor for me to be in this place and then wish Professor C.R.RAO the best for the coming months and years. I mean, it's really a great honor to be as part of the celebrations of the centennial of great C.R.RAO. Okay, so please convey my best regards to Professor Rao when you get a chance to meet. And I'm sure there are a lot of conferences being planned throughout the world. Okay, it richly deserves that. All right. Now, the outline of my presentation is going to be just give introduction and motivation for the subject, and then talk about batch Markov in arrival process, and then a little bit of few illustrative queuing models. Okay. Now, people may be wondering, why did I choose the title queues and services? Okay. At first thought, you will be thinking, wait a minute, queues means people are going to be served, right? If you really look at the general picture, um, if you look at anything we do in life, okay, in front of the computer, we are all spending almost every second these days, especially because of the COVID situation. So the technology is such that, okay, so we have the computers or the cell phones or cars, whatever you think about, they are all manufactured. Okay, so everything that we do in life is as either a manufacturing aspect to it, or a service aspect to it, or a combination of both. Okay, now if you look at the manufacturing part of it, okay, if you again think about the computers, okay, so the raw materials come into the picture, and these are assembled, either a semi-finished product being assembled to meet the requirements of the customers, or it is being built from scratch. In any case, these have to go through various workstations, okay, various assembly lines. Again, if you think about this as a car, from steel, it goes all the way through various stations where the engine is put in, the transmission is put in, the chassis, and all the stuff. Finally, you see a product, which is a car that people like you and me use that. Okay. So in the same aspect, if you look at it, when you buy a manufactured product, it has to go through sequence of operations. And if you really think about how it is being laid out, going from one station to the another station, there may be an intermediate buffer, right? So that's where the items are stored. So in this context, even though there are no customers, there are no patients, etc., jobs, and the messages that need to be processed, but still the items have to be processed to make this into a product. So in that aspect, queuing theory is used because you need to know where the bottlenecks are, right? Because if you are going to be allocating more resources to a particular node, and that is not going to be used properly, underutilized. How many times we have seen in day-to-day activities, some areas are overwhelmed, some areas are underwhelmed because you have so many resources being given to area where you don't really need. So it's not the money that is going to solve the problem all the time, but it is reallocating the resources. So that is exactly the reason why queuing plays a major role. Now, today, my presentation is going to be more in the area of service sectors, okay? Because there are a lot of things that have been done in the manufacturing area. There's also a lot have been done in the service industries, but things are changing. If you really look at it, one cannot even fathom how things are going to be 3 years from now, 5 years from now, okay? Now, I was fortunate enough to work with a professor by name Marcel F. Nuge. Some of you will probably know the person that I'm talking about. Unfortunately, he's no more, but he literally changed the concept, I should say, the subject queuing theory, where people thought the queuing theory is dead because the tools that are being used were outdated, and people thought that it's going to be not of much use for people to use in practice. See, sometimes what happens is, as we all know, okay, we all do things within the four walls, but how is it going to be really helpful to people who are going to be implementing them? So the physical aspect is one thing, the technical aspect is another thing. So in that context, so if you look at the service sectors, okay, how are they going to be playing a role? And that's exactly what we are going to talk about it. Again, there's a lot of materials to cover. Please let me know when I am going over time so that I can try to cut short my presentation. Unfortunately, I had some technical difficulty. For some reason, the sound coming from your end wasn't clear, so I had to log out and log in, and that took a few minutes away from my presentation. Again, my apologies for that. All right, so queuing models are still being used in many areas: telecommunications, service sectors, manufacturing, production, manufacturing systems, and you name it, even in the hospital sector. It's really unbelievable. You replace the jobs in the assembly line with patients, you replace the machines or operators with doctors and nurses, and the lab, lab technicians, and so on and so forth. Whatever we do in the context of manufacturing or service industries, applicable to other areas too. So healthcare industry is one such area where the queues are being extensively used, and they also benefit from the allocation of the resources, because we are at a point where those days are gone when people have the patience. Okay, you can sit for hours together before the computer gets connected, but now people want the results just after you log into the system, right? So speed is of essence now. So in any case, the um, the service aspect, the quality of service, and how the resources are being allocated are very key components to any study, and more so for management perspective. All right, so service sectors, service providers do not have unlimited resources. Okay, so because of that, they have to really optimize the usage of that. So again, I really want to go to the meat of the presentation here. Basically, if I just touched upon this assembly line and hospital setup and all this stuff. Now, this is something really interesting. Those days, people thought that simulation is the last resort. But recently, there is an article published by well-known authors, especially David Kelton is a premier in simulation, especially using the software called Arena. So I will just show that quote in just a second. So one way, see, remember, one of the criticism that we all faced, okay, in using operation research tools in real life applications is, sometimes we assume Poisson exponential assumption. The memoryless property of that may not be applicable to all kinds of applications. So we need to make sure the assumptions of the models that we present to some extent mimic the real life applications. Otherwise, you're going to make big mistakes in, you know, recommending what should work and what should not work. So that's the reason why sometimes, I'm not saying all the time we need to use, but sometimes one has to use other tools that are in the operation research techniques, okay? So again, there are several types of simulation softwares available. And of course, the one that I have been using it for my classroom as well as for my research is Arena. It's a Rockwell a company that is making that. Okay? Again, the point of this talk is to show you how we as operation researchers working in queues and other related areas can really help life much better for the community that we are serving, and we are part of the community. All right, so this is the code that I wanted to present to you, okay? So up until, a few decades ago, people thought that the simulation should be the last resort. When all else fails and you cannot use the real life assumptions into mathematical model, which complicates so much. I'm not talking about just using explicit expressions. Okay, those days are gone when one has to really look for explicit expression. Okay, so now even computationally, if you are able to get the solutions and use them in practice, that is really great, boom. However, if that is not possible, then what is the alternative? Okay, so that's exactly what these authors have been saying. Again, this is a paper that appeared in Naval Research Logistics just about a few years ago. So anyway, the paradigm shift here is simulation should be considered as a first resort as opposed to the last, okay? Of course, we have to we have to take everything with a pinch of salt. Okay, so everything has the best, everything has some negatives. So you look at the pros and cons and balance it out. All right. Now, what I would like to do is spend few minutes, okay, talking about again the importance of the Poisson exponential. Okay, mathematically they are very elegant, and they can also be used as some kind of an accuracy check. Oh, by the way, I forgot to ask you: is the slide font everything's fine at your end? Are you able to see it very clearly?
Yes, sir.
Okay, thank you.
Yeah, no problem.
Okay, thanks. So we all know the impact of Poisson process and exponential distribution in stochastic modeling, okay, among other areas. Now they have their own limitations too. So queuing models involving non-exponential assumptions have been mostly analyzed in a form that is not really conducive for practical implementation. Of course, things have changed. People have come up with the complex variable technique, root finding, and all the stuff. But still, if you look at, there are some cases where the roots are close to each other, and then if it is very close to zero, then you're going to have some kind of a problem. In any case, realizing this, Marcel Newts in early 70s and mid 70s generalized the Poisson processes to a class of distribution that is dense in the class of all non-negative distributions. Okay, so basically, if you can assume that the underlying distribution is now of phase-step distribution, then pretty much you can, approximate any non-negative distribution. Remember, when we are dealing with the service time, the arrival times, the lifetime, they're all non-negative. Okay, so we don't have to worry about, why are we focusing only on the non-negative part? Okay, so having said that, Newt developed the theory of phase-step distributions, and that got into one nice thing about the phase-step distributions is all you need is a matrix algebra background. Okay, so these days most undergraduate students have matrix background, so that's not going to be an issue for them. And secondly, if you look at the type of matrices analysis one needs to do, okay, you will see that it is very elegant, it's very compact. Now, so that resulted in Newts to go in full speed, starting from generalizing the Poisson process to phase-step distributions. And then what is the phase-step distribution? Phase-step distributions are nothing but, again, you have the, for both discrete and continuous time, but however, I'm going to focus on the continuous time. So imagine that you have a M state, Markov chain with an absorbing state, okay? Assume that it is an irreducible Markov chain. And so the matrix T that you see in the equation corresponds to the part of the governing with regards to the transient state. So when, again, assuming that T is non-singular, okay, you see that the process will, we start in one of those M transient states with probability 1, it will get absorbed, okay? Now, so the absorption corresponds to, for example, let's say you're trying to model a lifetime of a distribution using phase-step distribution. Then when an absorption occurs, that is the time when the component fade. Okay, the beauty of this is the Erlang hyperexponential mixtures. Okay, they're all specific cases of the phase-step distribution. And secondly, if you're trying to do a convolution and you're trying to look at the generalized Erlang. Okay, as you all know, Erlang is really, you go through several stages, and each stage you have the same exponential distribution with the rate, which is same for all the, let's say there are M stages in the Erlang distribution. But of course, if you want each stage to have its own exponential with a different rate, you can use that using the phase-step distribution, that is your generalized Erlang. Of course, that's only a tip of the iceberg, okay? But a lot of other distributions can be modeled. Again, as I said before, any non-negative distribution can be approximated because the class of phase-step distributions, continuous phase-step distribution, is dense in the set of all non-negative distribution on the positive axis, okay, from 0 to infinity. All right. Now this one, assuming that T is non-singular, the eventual absorption guaranteed, and vice versa. So again, how does your probability function looks like? Okay, so you'll see that again, if you recall if you start in one of those M transition states, according to the initial probability vector, say alpha. Now, if you are going to assume that, sometimes what happens is, especially the electrical engineers, they look at the off-wave rectifier where, there is a positive probability the lifetime could be 0. And if it is not, then it has a positive lifetime. Okay, so if you want to model that, then you can take this alpha m plus 1 to be a positive quantity. But in general, for most practical applications, alpha will be strictly a positive. Alpha will be strictly a probability vector, so alpha m plus 1 will be 0. All right, so with that being said, again, as I said before, these are all the special cases of the phase-step distributions, okay? All right, now on the beauty, again, in the undergraduate level, I tell the students that if you know how to model using exponential, hyper-exponential, and the Erlang, not even generalized Erlang, just the Erlang, they got the best picture in the sense that you have the coefficient of variation equal to 1 for exponential, less than 1 for Erlang, greater than 1 for hyper-exponential, and that way you cover pretty much all the cases to some extent at that level, okay? All right, now, seeing this, one of the problems is, again, in the service sectors as well as in the manufacturing sector, what happens is, if you look at the inter-arrival time between the jobs coming in or the patients coming into the system, okay, if you look at the successive inter-arrival time, they are not independent anymore, okay? So if that's, again, in the assembly line, if the raw materials are coming from various vendors to a common assembly line, so even if the inter-arrival time from each of those vendors are independent and identically distributed, but the pooled one may not be IAD case, unless you assume each one is a Poisson process. So if that's the case, then you are now ignoring the correlation that is inherent between two successive arrivals. So how do you model that? Because again, in real life applications, ignoring correlation as a severe consequences, okay? It's been proven in the last so many years, including some of my publications where I highlighted most of the time the positively correlated arrival process behave totally different compared to even hyper-exponential with a very high variation. Even with a very low variation in your positively correlated, it's a correlation that is causing the problem. Again, I'll show it to you quickly when we go into that particular area, okay? All right, so basically, the Markov arrival process, let me quickly explain that using a picture, okay? I'm sorry I have to quicken the process of my presentation because I'm looking at my watch here, and I know I have till 11:15, so I have only about 15 minutes or so. So I don't want to, not cover what I really wanted to cover, okay? So let me take this picture here. Okay, so what happens is, just imagine that you have a black box, okay, where there are some M transient states. So there are transitions going on within the black box, okay? Now, once in a way, there is a transition occurring outside the black box. So when you say outside, that means there is an absorption, okay, that is denoted by your star in the picture. So there are M transient states. So you stay in state I for an exponential amount of time with parameter lambda I. At the end of this sojourn, again, I'm explaining this in continuous time. So at the end of this sojourn in state I, one of two things will happen. Either the underlying process goes to another transient state J with probability given by Qij, or it goes to an absorbing state that corresponds to, in the context of the modeling arrival process, an arrival has occurred to the system. Okay, the arrival could be of batch size K, so the probability structure is given by Pij within superscript K. Now, at the end, okay, as soon as an absorption occurs, then you start in one of those M transient states according to the probability structure given by Pij. It depends. Okay, where you got absorbed is where you're going to get into starting the next arrival process transient state depends on from where you got absorbed from. That's why you see the dependence on the starting in one of those transient states by looking at Pij superscript K. Okay, so K is the batch size, I is the state from which the absorption occurred, and J is the state that you're going to visit. It is possible that you could start in state I again, okay, only through going through an absorption, okay? So that way, you're having this particular model. The beauty is, if I create a process that doesn't depend on the state from which it got absorbed from, so independent, let's say you do a multinomial independent trials to start in one of those M transient states, then you get the independent process. However, by having this, you model a variety of correlated processes. At the same time, you are generalizing the Poisson, you are generalizing the phase step distribution, and this is the original introduction by Newt was very complicated one. But later on, Newt and his students, okay, simplified this using the matrix notation that we are going to talk about, the decay matrices that we are talking about. Okay, so the simplification occurred, but still the original process introduced by Newt as versatile Markovian point process is same as the batch Markovian arrival process. Okay, sometimes in the literature people think that BMAP is different from VMPP and BMAP is due to somebody else. That's not true. Actually, BMAP is still Newt's process, but presented in a simplified way. But otherwise, the credit really goes to Newt and nobody else. And since then, a lot of publications have occurred in the batch Markovian arrival process. Again, these are all how you calculate the unit per, okay, the average rate of customers coming in, okay. You're talking about in terms of batch, it will be given by lambda G, but if you're talking in terms of the customers coming in, that is, what is the rate of customers coming in, you multiply the lambda G by the average batch size, then you get the number of customers per unit of time, okay. Now, what I would like to do is, again, these are all the expression that is already there in the literature, you can see that. And once you get this information, you can get the correlation between the n-1 lag correlation between the first interval time to the second or the third or the fourth, okay, however many you want. Now, the one nice thing about the BMAP is superposition of a finite number of BMAPs is also a BMAP. The dimension, of course, grows exponentially. And again, you need only a matrix algebra to model and do the analysis and calculate various system performance measures to be useful in practice. Okay. All right, now again, I'm going to skip these special cases, but I would like to show you the beauty of the BMAP through a picture here, okay? Again, sorry, I'm trying to quicken the process, but I'll be more than happy if anybody wants to discuss more on this. Not necessarily today, but any other day, I'll be more than happy. We can set up a meeting and we can chat on that, okay? And the beauty of this technology is such that we can all meet virtually and then share our ideas. Now, one of the questions that I always get asked by students and fellow researchers is, how do you choose like, for example, linear programming problems? Okay, people always have a test cases, okay? So if you're going to write a new software or going to have a new algorithm for computing the optimal solution, how do you know that really works under all scenarios? So you have the test cases. Similarly, how do you generate data for solving problems? Okay, fitting distribution is one thing. Okay, that is really an important problem, and still people are working on that. But I'm talking about generating examples for your model. So in that case, okay, the simple construction is given here, and this covers a variety of correlation in the picture. So basically, you take an Erlang of order k, and then you look at the mixture of those two. And by doing that, I want to show you, again, it's better to show you through a picture. Again, these are all the mathematics began. It's already in the paper that I will be happy to share that with anyone who is interested to see it. And some of them are already published, so it's still available. Some of them is coming in as a chapter in the book. Anyway, so I want to show you the picture, okay? This is a very important one. So how you would select the, for example, let's say you want to model a situation where you are expecting the correlation to be 0.57, okay, or it is negative correlation minus 0.57. So how do you choose the parameters? Now the beauty of this is, even though you see the correlation is different, they both have the same mean and the standard deviation, okay? So we took the mean to be 1, okay, where you see there. Now the standard deviation for the positively correlated and the negatively correlated are the same. However, if you look at the correlation, 1 lakh correlation, they are exactly opposite of each other. Now, that results in showing, this is just a graph to show you how you get different types of correlation by manipulating those parameters. Okay, so there is a restriction. If I take R equal to 0.1, okay, you can only have a maximum of correlation of 0.3, whether it's positive or negative. But if I take R equal to 5, again, what is this R? Again, you see that R is nothing but a multiple, okay, lambda here. So the two parameters, lambda 1 and lambda 2 that we are looking at, okay, one is the proportion to lambda 1, the proportionality is given by R. So based on that, again, you know, I hate to spend more time on this as opposed to going into queues and services, but this is an important input processes that people need to know. Okay, shy away from Poisson exponential, go into more versatile, and your model will be more applicable in real life applications. That is the theme of this presentation. So if you look at this graph, for example, so look at the one that is on the left side. Okay, the top one is the probability density function. Okay, that is the same for both positive and negatively correlated. However, the middle picture on the left is for the joint PDF function of math, which has the negative correlation, and they look at the one that is positively correlated. So if somebody is going to ignore the correlation present, then you're going to get totally different results, because the joint probability function is completely different from each other. Okay, so you cannot, it's like, you know, remember way back we used to say, you know, mean alone is not going to be a good measure. You have to look at the standard deviation. Now we go even beyond that. Okay, all right. Now, one of the applications that I would like to talk and then probably end at this stage, and then open it up for questions and answers, is the Internet of Things. We are all driven by how the technology is changing, right? Your refrigerator at home is so smart. It knows that, okay, you are low on milk, you are low on some dairy products, so you are low on bread, so I'm going to order type of thing. So when you do that, how do queuing theories utilize and help the service providers? Okay, so that is sort of a very interesting one, and this is the beauty of using the map in that context. So the motivation is really more and more people are using it, and billions of dollars are being used, and they are saying that by the time, you know, another couple of years, you are talking about several billion devices will be connected to the Internet of Things, you know, application. So again, the objective here is to see how we can use the batch Markov iterative process and how one can help. So I'm going to show you the summary of that. Okay. So again, when you look at the quantification of the number of needed resources, okay, coupled with the again, the point here is nobody has unlimited resources. So how do you find appropriate service provider to find what is required and then send those items to the customers? Okay, and again, even a small service provider can benefit greatly by part of that. Okay, so the assignment of a service provider in the case of a multi-service provider system can be looked upon from customer's point of view as well as from the service point of view. So one can introduce, again, there are a lot of problems, future work available, and this is under review, and I'll be more than happy to share the final version of that. I am not sure how much time I have, so I would appreciate if you can tell me I'm out of time, then I will stop and ask people to participate. If you think I have some more time, then I don't mind spending some time on that too. Please advise me.
Yes, Professor Chakravarti, thank you very much for nice illuminating on this area QC and services. And definitely, I can request the audience if there is any question, please you can ask.
Okay. So please. Okay. So are you telling me that I have a couple of more minutes, or I want me to stop it?
Actually, as per the time schedule, you
Okay. That's fine. That's fine. That's okay. That's not a problem. I appreciate that. Thank you
and
very much.
yeah, yeah.
Again, I
And
appreciate.
I can say that you are the man of management also. Definitely, you managed your talk within the time. And although we started late, and
Yeah,
Professor,
I understand the
I,
time pressure that organizers have to go through,
yeah,
so
yeah,
that's why I don't want to have a
yeah,
dominant effect on
yeah,
that.
yeah. Professor Chakravarti, I have one question. Yeah,
Go ahead.
yeah,
Go ahead.
yes. Generally, in stochastic modeling, we have some states, regenerative states and non-regenerative states. Regenerative
Right.
state and non-regenerative states and transient state. Transient states are something different.
Correct.
In case of non-regenerative state, can we call these follow the Markovian property?
See, in that case, you need to use, embedded processes. Okay, rather than looking at the arbitrary time, you have to look at the times where certain events occur. For example, if you look at the NG1 type of cube, then you look at the departure epochs, so that at those epochs, you'll have a regenerative property will go through. But if you have a situation where you cannot do it, like for example, the GIG1 type of cube or GIGC type of cube, that's when I was talking about the simulation thing, because the last few years I was looking at, for example, the busy period analysis, one of the most difficult problems in queuing theory. Okay, so, and even for the MM1 case, if you look at the expression for the busy period analysis, it's not that simple. So imagine how people are going to do it for a multi-server and also for a GIG1 type of GIGC type of queues. So in that case, I think the best option would be to use some kind of a simulation. After you validate, you can do that. But theoretically, to talk about, if you don't want to look at it, those embedded points to get the regenerative process, then your options are very limited, unless you do some kind of an approximation or use simulation, or maybe relax some of the assumption, or maybe put more restriction on the assumptions of the model.
Yeah, yeah. So one more thing that you rightly pointed out, that generally we assume that the occurrences of the events are independent to each other. But you rightly
Correct.
pointed out that there is some correlation. There is some correlation between the occurrences, and generally we.
Exactly.
Yeah, yes. So is there
Exactly.
any, yeah, please. Is there any question from the audience side? Any query? So, okay, thank you very much, Professor Srinivas Chakravarti, and we hope that we will in touch in the coming years or coming days.
Okay, definitely. Thank you very much, Professor Malik, and my best wishes to everyone and amazingly organized conference.
Thank you,
Thank,
sir.
thank you,
So,
Srinivas. Thank you.
thank you.
Thank you.
Okay,
Take
thank you.
care.
Okay. So, in the
Bye.
next lecture, we have uh, another talk by Professor Sopan Bhattacharya. Yeah, is available?
No, because just now I called him. He
Okay.
said that because of his health is not doing well, so that
Okay. Okay.
yeah.
So we have then next Professor Najipan Subramaniam. Is he available?
So he is from UK, but maybe the timing is
Oh,
bit, yeah. Now, meanwhile, I requested Professor Chandra from IIT Delhi.
okay,
She is
okay.
she is ready by 10:15. Meanwhile,
10.
we'll,
Okay.
yeah, meanwhile this half an hour we will screen this Professor P.R. Rao birthday cake cutting ceremony function. So that we will screen. Yeah.
Okay.
So I request you, Malik, could you have it for a class, half an
Yeah.
hour?
Half an hour?
So if
Yes.
you,
No
yeah,
problem. You can
yeah, if you wish to take, you take it, no problem.
talk today. Just now.
Yeah, just no, because of this flat, no, because
Okay.
now
Okay.
she
Okay.
called me. So,
Okay. So the can I take 5 minutes?
yeah, yeah, no problem.
Yeah.
Meanwhile, for 10 minutes, we will put it that birthday cake setting. As soon as you are ready, we will start it.
Okay.
Okay?
Okay. Okay.
Yeah. But you keep that. Malik వచ్చింది lecture మీద. Sir Malik? Malik, are you ready?
Within 2 minutes, within 2 minutes.
Yeah, if it is ready, okay, you can start your lecture. No problem.
Yeah, Professor. Yes, Professor Reddy, I'm ready to start the lecture.
Thank you, yeah. Malik.
Yeah, yes. So definitely again I'm very grateful to Professor Reddy to give me a chance to present something in the field of reliability improvement techniques. Though we have several reliability improvement techniques, but the main one is the components structure, or you can say configuration, has played a great role in reliability improvement of the system. So in this talk we shall discuss role of components configurations in reliability improvement of systems. Yes, we shall cover the importance of the subject, some fundamentals, reliability data, some case studies through which we can say that component structure played an important role in reliability improvement. Then we made some conclusion and the motivation for the present lecture. Then question arises sometimes why we take or why we choose the research work in the subject reliability. Basically, the interest of the researcher in the subject of reliability is only to assess the reputation of any industry or company or institution is closely related with the reliability of its product or its elements. If the products are more reliable, then definitely more favorable chances of the reputation of the producers. Then another aspect to consider the research area in the field of reliability is the customer satisfaction. High reliability, actually, for the reliability of the system, there is a need the customer satisfaction. So high reliability is mandatory requirement for the customer satisfaction. Then we need to discuss the warranty cost. If our product is reliable to use or is of high quality, then definitely the warranty cost will be less. Because if we produce a particular system or a component, then we provide some time that during that time the system will work perfectly. But it is not there is no guarantee that the system will do or will work perfectly. But for at least for a given period, we can assume that the system will work. That period is called the warranty period. If product is of highly reliable, or we can say that having good quality, then definitely the warranty cost will be less, because there will be less number of repairs and maintenance there. So we can have an advantages of the warranty cost when the product is of highly reliable. Then it helps in repeating the business. If our product is good to use, then definitely again we shall buy the product again and again. So it helps in repeating the business. Cost analysis we can carry out with the help of the reliability data. How we can carry out cost analysis? There is no doubt that to produce a reliable product is very cumbersome, but there is a need to maintain the cost optimally. There is a need to make an optimal balance between the cost of the production, cost of the operation, and the reliability of the product. So in that situation, if we see the overall cost of the, we can say the life cycle cost of the product, then definitely it will be less as compared to the other products which are less in reliability. So we can carry out the cost analysis on the basis of the reliability of the product. So there is always a competitive advantages of the reliable product or the less reliable products. So these are the few factors because of which there is a need to carry out the research work in the field of the reliability. So now another question is, what types of systems we should consider, and how we can design the components in a particular system so that the system will have more reliability, or we can say will have less number of difficulties while using by the customers. So there is a need to understand system. First, system, generally we discuss several types of system. First there is a need to understand system. System means the collection of components which are designed to provide acceptable system performance with reliable measures. So system basically is a collection of components designed according to a specific design to provide or to assess or to attract system performance with reliable measures. So system basically is a collection of components. So now the structure of the components plays an important role to improve the system reliability. Now, what types of structures we can consider in a system? Generally, if we consider the case of reliability engineering, in reliability engineering, we generally deal with some well-known structures: series structure, parallel structure, series parallel structure, parallel series structure. Now, what do we mean by series structure? We mean if a system has components connected in series, it means the failure of a single component causes the failure of the entire system. That is, system cannot survive with the failure of a single component. So it means for a series component, there is a need of the operation of all components working in the system. So now another structure is the parallel structure. Parallel structure means that is the system in which components are arranged in such a way that the system will survive till the failure of the last component. That type of structure is the parallel structure. Then we have another type of mixed mode type structure called series parallel and parallel series. In case of series parallel, we have suppose a system, main system, in which there are several subsystems. But if the subsystems are connected in series, and in each subsystem, the components are connected in parallel, such type of structure is a series parallel structure. Now, another type of structure is the parallel series structure. In case of parallel series structure, suppose we have a main system in which some subsystems are working. But if the subsystems are working in parallel and in each subsystems components are connected in series, that type of structure is called a parallel series structure. So, and we have other types of structure also, K out of N structure and non-series parallel structure also we have. So there are several types of structures in the engineering field which are required to design or to manufacture a system in a better way, so that that system can be used to with a considerable reliable aspect. So now we determine there is a need to assess the two types of reliability measures. Generally, we determine reliability and mean time to system failure for a particular system. Reliability means the probability of no failure. That is reliability. So reliability is the probability. That is the system will work at least for a given period of time. Suppose given period of time is small t and capital T is the survival time of the system, then definitely reliability means the probability that capital T is greater than small t. Otherwise, the system will not be considered as reliable. So reliability means the probability of a device performing its purpose adequately at least for a given period of time under stated under, or you can say working under some stated conditions. So it is reliability. Then we determine mean time to system failure. Mean time to system failure means the expected time before the system completely fail. Expected time of the system survival. So if we consider t is the time survival time, then expected time of t is the integral of ftdt. That is the failure density function. So we can determine MTSF as the expected value of capital T. There is a relation between reliability and MTSF. If reliability is known, then we can determine mean time to system failure. If mean time to system failure is known, then we can determine the reliability. Sometimes we have system has the requirement to the system is of reliability. Sometimes the requirement to the system is mean time to system failure. So we can obtain there is a relation. If we know reliability, then mean time to system failure into the reliability given by just the integral of the reliability from time 0 to infinite. So this will be the mean time to system failure. So these two measures generally we determine in case of engineering systems. So now this is the reliability data. From this data, we can make conclusion that structure of the components plays an important role to improve the reliability of the system. Suppose we have a system. Our interest is to develop a system with reliability 0.95. Then definitely we need to design the system having reliability 0.95. For this, suppose we are considering 10 components, identical components having constant failure rate, say 0.2, 0.3, or in general we can take lambda constant failure rate, or we can say suppose the components follow failure time of the components follow exponential distribution, negative exponential distribution. So in that situation, suppose our interest is to develop the system with reliability 0.95 with 10 number of components, identical components. Then in that case, if we join the components in a series structure, then we need the components reliability 0.9949. What does it mean? It means the system reliability is 0.95, but components reliability is required 0.99. What does it mean? For a series structure, we need the components reliability higher than that of the system reliability. But if we design the same number of components for the same objective, then in a parallel structure, then we need only the component reliability 0.26, or we can say 0.2581. What does it mean? The parallel structure of the component is better than that of the series structure of the components. Now, if we consider the another structure, series parallel, but series, there are two possibilities in case of series parallel. Maybe having more number of subsystems, less number of components, because we have only 10 number of components to make the system. But the possible arrangement of these 10 number of components may be in subsystem, then in subsystem, and in each subsystem the components may be included. So suppose we have 10 number of components. Suppose our interest is to develop the series parallel system with 5 subsystems, and then definitely in each subsystem we can take 2 components. In that situation, the component reliability required is 0.8990. Again, if we consider 2 subsystems with 5 number of components, then we need component reliability 0.206. So we go on comparison, we can say that in that situation, series parallel structure having more subsystem is less helpful in improving the system reliability. Another, if we consider another parallel series structure with the same configurations of the components, then we need, in case of two subsystems with 5 components, we need the component reliability 0.9506. If we take 5 subsystems with 2 components, then we need component reliability 0.6714. So entirely, if we see the data, reliability data, then we can conclude that component structure in a system plays an important role to improve the system reliability. Therefore, it is a suggestion to every academic institution and every engineer and every system designer that while developing a system, there is a need to decide the better structure of the components so that system can have more reliability and will have less number of difficulties for the customers. So we can say that structure of the components plays an important role to improve the system reliability. Now we shall discuss some particular cases. Suppose we are considering, we determine reliability and mean time to system failure with the series component configuration. Suppose we have a system of n components which are connected in series with given reliability R1, R2, and Rn. Then if we assume RT is the reliability of the entire system, RIT is the reliability of the ith components, and HT the instantaneous failure rate, or you can say hazard rate of the entire system, and HIT is the hazard rate of the ith component. And if we take lambda the constant failure rate, T is the lifetime of the system, Ti is the lifetime of the ith component, then we have the reliability of a series system at time t is given by probability that capital T is greater than T, because it is a series configuration. So we need the survival of the least or the weakest component so that the system can survive. So it means if we need the minimum survival time of the components must be greater than T. The probability of minimum survival time greater than T is the reliability in case of series structure, or we can write it as probability T1 greater than T, T2 greater than T, like this, because all these we are considering here independent to each other, so becomes the product. So product of the reliability of all the components. So we can say that reliability of the entire system, if the components are connected in series, is the product of the reliability of the components because we are considering there n components, the product of the n components, that is product of the reliability of the n components to give the reliability of the entire system. Yes, general, but sometimes we need to consider the failure rate of the components. Suppose in general, if we take hazard rate, HIT, that is the failure rate of the ith component, then reliability we can have, reliability of the ith component is equal to the equal to the e raised power minus 0 to t integral of the hazard rate. Then the reliability of the entire system, because it is the product of the reliability of the component, so it becomes this expression. So we can have integral of the e raised power minus integral from 0 to t HUDU. So the here in a series structure, the hazard rate of the entire system, whole system, will be the sum of the hazard rate of the components. Similarly, now we need to determine mean time to system failure. As you might be knowing that mean time to system failure is just the integral of the reliability from 0 to t. So put the value of reliability, that is in case of series, which is the product of the reliability of the components. So we can have the value of the mean time to system failure. If we consider some particular cases, particular situation, then for a single component system with failure rate lambda equal to lambda, we here consider a single component. In case of single component, there is no need to consider the structure, whether it is parallel series, no need, because we are dealing with a single component system. So no need to take, it means all lambda is equal to lambda equal to lambda. So in this case, reliability will be e raised power 1 lambda t becomes e raised power 1 lambda t, empty, so will be 1 over lambda. So we can say that the mean time to system failure of a component having constant failure rate will be reciprocal of the failure rate, that is 1 by lambda. But if we consider two components, then here structure plays role. If we take two components in a system which are connected in parallel, connected in series, then we can have the reliability as we already discussed, the product of the reliability of the component, that is product of these two, reliability e raised power minus lambda it. This becomes, because of the mathematics, e raised power minus lambda 1 plus lambda 2 t. So if the components are identical in nature, then it becomes 1 over 2 lambda t MTS of, and the reliability becomes e raised power minus 2 lambda t for identical components. So in a similar way, we can determine the reliability of other components. So now consider the case of reliability and MTS of mean time to system failure of with parallel configuration. Suppose we are dealing with a parallel system having n components connected in parallel. These components are C1, C2, and Cn. So if we determine the reliability of this system, then as per definition, reliability is just the probability that t greater than t, which is by probability theory 1 minus probability t, capital T less than t. So it means we need to determine probability that the maximum of the lifetime is less than equal to t, because in case of parallel structure, the system will work till the failure of the last component. Then we have the reliability of a parallel structure is 1 minus product I minus 1, because this is the reciprocal. If we consider the reciprocal, it becomes the unreliability 1 minus RIT. So in case of parallel system, the reliability is given by 1 minus product of the number of components of the product of the components unreliability. 1 minus RIT means unreliability product. So this is the formula through which can be used to determine the reliability of the system. Yes, for particular situation, so if we take a single has components with failure rate lambda I, then RIT will be e raised power minus lambda IT. Then put their values in the system reliability. We have RT equal to 1 minus product I from 1 to n, 1 minus e raised power minus lambda IT. Put all these values and use probability theory laws, then we can have this expression. Similarly, we can determine mean time to system failure here like this. So now we consider some particular situation. Suppose the system has two components, C1 and C2, then the reliability of the parallel configuration will be by 1 minus the product of unreliability of the components, that is 1 minus RIT. Then we can determine for identical components, we have the reliability will be 2 raised power 2 into e raised power minus lambda t minus e raised power minus 2 lambda t, and the MTS will be by 3 by 2 times 1 by lambda. So this will be the mean time to system failure in case system has two identical components in parallel. Then the MTS will be 3 by 2 into 1 by lambda, and reliability will be given by 2 into e raised power minus lambda t minus e raised power minus lambda t. So we can have. So these are the particular situation values. So if we see the table 1, then we have both type of structures, parallel structure and series structure. Suppose we have a single component, then the reliability will be 0.9048 in case of parallel, and series in case, because it is a single component structure, so reliability will be same. But if we increase the components from 1 to 2, if we take 2 components, the reliability will be 0.99. It means in a parallel structure, reliability increase, but in a series structure, reliability decrease from 0.90 to 0.81. So we can say that components, number of components and structure and their structure plays an important role to increase the reliability of the system. Similarly, we can show these by graphs. Now we shall have the effect of the operating time also on reliability. If we increase the operating time from 5 to 10 units of time, then reliability with series system becomes less, 0.95 to 0.90. But in case of parallel, it also becomes less, because if we increase the operating time, reliability becomes less. Definitely, there is no effect of the structure here. But if we increase the number of components, then it becomes less in case of series structure, because initially it was 0.9048, then it becomes 0.8187, but it becomes more in case of parallel structure. So, but operating time has the impact that has the impact that if we increase the operating time, then the reliability will decrease in both cases, whether it is a series structure, whether it is a parallel structure. Now we shall discuss the reliability and mean time to system of MT sub of a system with more complex configuration, that is series parallel configuration. Let's consider the case of MN order series parallel structure. MN order means we have M number of subsystems, first subsystem, second subsystem, and mth subsystem, which are connected in series, so-called series. But in each subsystem, suppose we have n number of components connected in parallel, so-called parallel series parallel. So because we have m number of components, m number of subsystems which are connected in series, and in each subsystem components are connected in parallel, and we each has n number of components. So that's why this is called a series parallel structure of MN order. Then if we assume RT is related to the system, RIT is related to the components, hazard rate for the entire system, hazard rate of the components, and constant failure rate, T is the lifetime of the system, TI is the lifetime of the components, then in this situation, the reliability of the entire system will be the product, because subsystems are connected in series. First, there is a need to determine the reliability of the subsystem, then consider the idea of the series connection, then we have product. So in this situation, in a series parallel structure, we have reliability of the system will be product of the number of the reliability of each subsystem, reliability of each subsystem. But reliability of each, because in each subsystem components are connected in parallel, so it means the reliability of the parallel system. So we have m subsystems which are having components connected in parallel. So reliability will begin by J from product of all the reliability of the subsystem, that is 1 minus product I from 1 to n, 1 minus RIT. Or if the components, because this is all are equal, because each subsystem has same number of components, the reliability of each subsystem is same, so the product becomes m power m, so it will be the power m value. Similarly, we can determine mean time to failure, that's just the integral of the reliability. Some particle, if we consider the case that is the hazard rate is of constant nature, then reliability of the system will be given by this, and mean time system will be given by this. So, but if we take all the components are identical in nature, that is having the same failure rate, constant failure rate lambda, then reliability becomes 1 minus e raised power minus lambda t power n raised power whole power m, and MTSF will be this much. So after using some mathematical derivations or integral rules, then we can have MTSF and reliability of the system for a series parallel structure. For particular situation, if we take m is equal to 1, then it becomes the same result as for a single parallel system. No need to calculate. These are the particular situation. So, but one more thing is that with the help, if suppose reliability of the entire system is known and reliability of the components is known, then we can determine how many components are required to provide that reliability. So with the given reliability of the system, with the given reliability of the component, we can determine how many components are required to develop the system. That is the formula n. Small n gives the number of components required to develop the system with reliability capital RT and component reliability PT. So this is the formula from which can be used to determine the number of components used to develop the system with the required reliability of the system as well as components. So n is given by log of 1 minus RT raised power 1 by m divided by log of 1 minus PT. So this is the formula which can be used to determine the system components, number of system components. So now similarly we can determine reliability and mean time to system failure of system with parallel series configuration. In case of parallel series configuration, this is just the mixed mode structure, because in parallel we are considering parallel. It means we have series, then we have m number of subsystems connected in parallel. This is the first subsystem, second subsystem, mth subsystem, which are connected in parallel subsystem, but in each subsystem the components are connected in series. That's why we call it as parallel series configuration. So in this case we can determine the reliability by this. RST is given by, because the structures are in subsystems are in parallel, but each subsystem has components connected in series. So we use the parallel method within the series method. So we can have 1 minus product J from 1 to M, 1 minus product of RIT. So this is the reliability of the system for parallel series structure. Similarly, we can determine the mean time to system. For particular situation, if we take the hazard rate constant, then we can have the reliability of the system given by this and mean time to system failure given by this. So for particular situation, if we take all the components are identical in nature, or you can say that is having the same failure rate, then we can determine the reliability of the system equal to 1 minus e to the power minus n lambda t power m, and integral of the reliability is the mean time to system failure. By using some mathematical or integral theory, then we can have the results like this. So we can determine. Similarly, here we can determine now in this case, we can determine the number of subsystems required. This is M means the number of subsystems required. In case of series parallel configuration, we can have the formula for determining the number of components. But in case of parallel series structure, we can determine number of subsystems required to develop the system with reliability RST and component reliability PT. So these number of components are required. That is log of 1 minus RST divided by log of 1 minus PT power n for particular situation. And also we can determine the number of components also. As a whole, we can determine the number of components as well as the number of subsystems required to develop the system with the components reliability, with given components reliability and system reliability. So these two formulas can be used, which are very interesting to note here. Then similarly, if we see the variation in reliability and MTS for a series parallel system for particular values of the parameters, suppose we are taking here M, the number of subsystems, and the number of components in a. If we consider the case of a subsystem having only just 5 number of components with same failure rate 0.01 and operating time 10, then if we see this table, then we will have the reliability increases with the increase of the number of components because the components are in parallel. So it helps in improving the system reliability. But if we increase the failure rate from 0.01 to 0.02, then there is a decline in the reliability of the system. See, but that can be managed. That can be managed by increasing the number of components, number of subsystems. If we increase the number of subsystems, then because the subsystems are connected in series, so it again reduces the reliability of the system, entire system. So we can have the variation in reliability and mean time to system with respect to the number of subsystems and with respect to the number of components, with respect to the failure rate and with respect to the operating time. So we can show graphically that as we have already discussed in the table. So we have, so similarly we can obtain the reliability and mean time to system failure for a parallel series structure. We have some very interesting results. So finally we conclude that, what is the conclusion of this present talk? We conclude that a series parallel system is more reliable to use than that of the parallel series, provided components are identical in nature and follow exponential failure law. These results are only applicable when components are identical in nature, having constant failure rate. Otherwise, we cannot say that series parallel structure is better than that of the parallel series structure. So these are the references used to develop the talk. Thank you. Professor Reddy.
Any questions from the audience?
Yeah.
Yeah. If nobody is there. Okay. Thank you, Professor Malik, for the nice presentation. Now I am happy to introduce Professor Chandra. Yeah, Professor Chandra, Madam is available. Yeah. Okay. Now the next lecture, so that I am happy to introduce Dr. B. Chandra, He is currently an adjunct professor at the School of IT, Indian Institute of Technology, Delhi. He served the Department of Mathematics, Math, IIT Delhi as a professor from 1979 till June 2016. During her tenure, she was the head of the department for 3 years and was deeply involved in the curriculum of MTech program in math and computing. She was the chief data scientist for more than a year from August 2016 and subsequently as a consultant in machine learning in an artificial intelligence company till recently. Her specialization areas include machine learning, deep learning, neural network, databases, and adaptive forecasting. She has guided a number of PhD students in these areas at IIT Delhi. She has published more than 150 research papers in reputed international journals in the areas mentioned above. She has authored 3 books. She is a senior member of IEEE Computer Society. She has been a visiting professor for a year with the Graduate School of Business University of Pittsburgh, USA, and for a year at Penn State University, University Park, USA. She has also been a visiting scientist at NIST, Maryland, and India, France. She has delivered talks in several universities in USA, Canada, Korea, France, UK, Singapore. She has been the chief investigator for several projects funded by DST, DBT, DRDO, Planning Commission. She is the author of 5 books. In October 2020, the patent for which she is the inventor has been granted, and she is having very apart from that she is having very close relationship with Professor C.R.RAO since 1977. As the advisor of Professor C.R.RAO, Professor Chandra delivered the keynote address at the workshop on pattern classification organized by Professor C.R.RAO at Penn State University. At the invitation of Professor C.R.RAO, Professor Chandra delivered several invited talks at Penn State University. Now I request Professor Madam Chandra to speak. I have also request Professor S.C. Malik to chair this session. Thank you.
Thank you, sir.
Please unmute your mic, madam.
After this Madam lecture, then Nachappan lecture will continue.
Okay.
Madam, please unmute your mic, madam.
Yeah, please unmute your mic, madam ji. Professor Chandra, please unmute your mic. Professor Chandra, please unmute your mic. Yeah.
I've done that. I've done that.
Thank you. Thank you.
Okay. And for presenting, I will your entire screen. Which one?
Select the screen, then you can the share option will be enabled.
Share. Share the screen, no? That's what I should do. Share option is not coming.
No, madam, select on the screen, madam. Click on the screen,
And?
then
Yeah, my slides, how to share other. Share option is not clicking other.
no, madam, click on the screen, madam. The window is screen.
Okay, click on the screen. Which screen? Okay, my PPT is on, then
No, madam, the share option will be enabled if you click on the screen in the window.
In that. Yeah, that's right. Okay, yeah.
There it is presenting, madam.
Now you are able to see?
Yes,
madam,
sir. Yes.
Yeah. say good morning to everyone, and I thank Professor Reddy for arranging this talk. And I would like to, first of all, at least pay my respects to Professor C.R. Rao, whom I know from the student days, right, from 1976, rather. Like, it was such a memorable experience, and we visited him. He wanted me to visit him last year. We went to his house. He was so delighted to see me, rather, and my husband and my daughter, everybody. He then he took us to all the rooms, and he showed Washington Science Museum how his photographs is displayed, and all entire pictures with Indira Gandhi, Morarji Desai, Manmohan Singh, all these people, how the all the pictures he showed. And then his daughter was asking, "You are awake for 3 or 4 hours. Are you not feeling sleepy?" He said, "Chandra has come." Now no sleep is necessary, he said, rather. So he is, and 1976, he met me at the University of Delhi when I was a student of a PhD. And then I just shared my work with him. And he said that it's excellent work, you send it for publication. But due to teaching commitments, I was little busy and I was delaying it. Next year, after 8 months, he came to Delhi University again to give a talk. And then, Chandra, where is your paper work? It's a good for publication, Sankhya Series B. And he remembered, my goodness, he remembered so much. And then I submitted to Sankhya. It is published there also. Then in 79, he wanted me to join University of Pittsburgh, but at the same time, I joined IIT Delhi. I didn't want to quit that. And then in 1981, he invited me to University of Pittsburgh during summer. Then again in 1984, he gave an excellent recommendation for me to become a visiting professor at the School of Business at the University of Pittsburgh. And see, initially, when you go to a town, you cannot find an accommodation. He fixed up an accommodation for the initial days. I was not married at that time. Myself and my mother stayed at his place for 5-6 days, rather. I think his hospitality and his wife's hospitality I can never forget, rather. Then he invited me for a year from between 1980 and 1998 and 1999. Visited the Penn State University Center for Multivariate Analysis, taught courses there, and he organized a workshop on pattern recognition. He wanted me to be the keynote speaker in that. Myself, one Brazilian scientist, rather. And it went off very well. And several times he has invited me to Penn State to give invited talks. I can never forget. And the one I'm meeting with him last year was a memorable thing. He's really gem of a person, not only a great statistician, but gem of a person too. I always remember him, brother. Let me have this talk. This one was one of the work with my PhD student. Before we submitted to the journal, I wanted to have an opinion from Professor C.R. Rao whether it is a good work or not. He said, "No, it's excellent. I am also fond of this gene expression and all that. His genetics and all that. You should submit, and it's excellent work," he said, rather. So that's I think all credit goes to him, brother. That's. See, any pattern classification problem, it's Professor C.R. Rao is also very fond of this data set, rather. Fisher's iris data set. Any pattern classification problem, you have, can you all see the slides properly?
Yes, madam.
Yeah. Okay. So
Madam,
it is like,
madam, try to complete by 25 by madam after 25 minutes. After
Okay,
that,
sure.
there is class. Yeah.
Okay. And then see, Fisher's iris data looks like this. There are 4 features. R.A. Fisher statistic, all of you know. He was very fond of collecting flowers. There are 3 kinds of flowers: Iris setosa, Iris versicolor, and Iris virginica. he collected information regarding the sepal length, sepal width, petal length, and petal width of each flower, rather, and then classification of these three categories, whether setosa, versicolor, or virginica, rather. So the data set, if you just Google and find out, you will find the data set like this. That is the ranges of sepal length, sepal width. For setosa, how does it look? For versicolor, virginica, R.A. Fisher collected 150 patterns like this. 50 of setosa category, 50 of versicolor category, and 50 of virginica category. So, so now we talk of machine learning, everything. Unless you select good features for a pattern classification problem, there you cannot get good results at all, rather. So what is feature selection, Lindsay? To select a subset of features based on relevance and redundancy in providing information. Finding a good feature set is an important problem for data sets. And so what is that? A good subset. If you select a good subset, and you can simplify the data description, improve the classification accuracy and performance. What are the major advantages of this for classification by using feature selection? That is reduction in computational cost and better classification accuracy. So what are we aiming at in feature selection? Finding an optimal feature subset in a computationally complex problem for many real-world problems. So people will ask the question, why not use entire feature set? But it is very expensive, and to examine all the features, and the foremost important thing is irrelevant features do not contribute to provide additional information at all, rather. So let's come to this problem. So what did we do? There are so many ways of feature selection. They call it like what is called a filter-based approach, wrapper-based approach. So they are quite, so select them, like what you do is you examine all combinations of feature subsets and find out which gives the maximum classification accuracy complete. This will be very expensive, computationally expensive. Or under some guidance, you try to see the combinations of features F1, F2, F3, and combination of F2, F3 like that. Again, how do we know these subsets are correct, rather? So we have, like myself and my PhD student, we have developed what is called an efficient filter-based approach for selection in order to overcome the limitations of earlier algorithms. And so, and then let me switch off my phone. And then here, then you can select the important features and rank the features in any data. We have developed for gene expression data, but it can be used for any kind of data in pattern classification. This has been published in Journal of Biomedical Informatics, and it has so many citations, Elsevier journal. So what is the motivation for the proposed feature selection approach? This introduces statistically defined effective range to overcome the problems of outliers and higher class variance. What is the best part of this is that it distribution free. We did not see what kind of distribution does it follow, normal, Poisson, like that. We don't have to see, it is distribution free. That's the best advantage. So this effective range-based gene selection algorithm utilizes the concept of what is called interval estimate for defining the effective ranges of features for every class for a given feature. So the feature weights are computed using effective ranges of each class for that feature. Then what we do is, the effective range is also based on Chebyshev's inequality, which is true for all distributions. That is why we say that this technique is distribution free, rather. Class prior probability is also taken into account for defining effective range. A feature, like I talked of feature like petal length, petal width, and so on. A feature is given more weight if the decision boundaries among classes are far apart. That is, the classes can be easily distinguished. So what do we do rather? Effective range we define. So let's say X be the feature set of data set of size n. And then what is an effective range? Effective range is nothing but that is the Rij, that is the set Rij minus and Rij plus. Rij minus is the lower bounds of the effective range. Rij plus is the upper bound of the effective range. Standard deviation of xi, that is each feature for a class, and then mean of each feature for a class, and then pj is a prior probability of a class rather. The value in this you find that this is mu ij minus 1 minus pj, that is a prior probability, times gamma times sigma ij, that is a standard deviation, and then the other one is mu ij plus 1 minus pj gamma sigma ij, where value of gamma is determined statistically by Chebyshev inequality defined by probability of x minus mu ij is greater than or equal to gamma sigma ij is less than or equal to 1 by gamma squared. It is well known that for all for every distribution gamma 1.723, within that this works very well rather. So let's see. So what does the algorithm do rather? Compute the effective ranges for all classes for each feature. Like in the iris dataset, we had 4 features. That means for all the 4 features, we will do for all classes C1, C2, C3, like iris setosa, versicolor, virginica. Find out the effective ranges and sort the effective lower value of ranges of classes in ascending order of lower range to compute how much is the overlap between the features rather. Compute the overlapping area among classes of feature xi. So whenever there is overlap, so find out the sum of all the overlapping areas by this double summation phi I jk. And so when will there be overlap? If Rij plus is greater than Rij minus, so there will be an overlap. Otherwise, it will be 0. Then what we do, in order to compact and normalize a thing, compute area coefficient, which is the overlapping area by max of Rij plus minus min of Rij minus. So if a feature is having wide range, chances of overlapping with other features values is high, and that is why we divide by max of Rij plus minus min of Rij minus. And then we find out the compute the normalized area coefficient, that is ACI by max of this thing. And then how is the weight of each feature computed? By 1 minus the normalized area coefficient. The best part is it gives the values weight for each feature in the range 0 to 1 rather. Now let's see. The iris data set is there. So there are the different 3 classes are there, 4 features are there. So if you see feature 1 and feature 2, there is a lot of overlap between the features for class 1, feature 1 and feature 2. Let's see, feature 1 for 3 classes, there are a lot of overlap. Red, blue, and that other one black. These are all overlapping too much. But when you see feature 3 and feature 4, there is very little overlap. We can indicate that this one will be class 1, class 2, class 3 like that. But feature 1 and feature 2, if we take alone, there will be so much overlap and the classification accuracy will be very bad rather. So here it is illustrated this how the effective range gene feature selection algorithm has been illustrated on iris data. Just see, let me put it in this mode, that is the slide mode, then it will be okay. Can you all see this, or should I zoom it? Should I zoom more?
Yeah. You need to do more.
But slide more. Let me see. I'll zoom. Now you can see?
Yes,
Yeah.
little more. Yes,
See
yes, no problem now.
how that this works. Let's see. Now, feature one. Now, if you see, let me zoom little bit. Feature 1, data range is 4.3 to 5.8 for class C1 and 4.9 to 7.0 for C2, 4.9 to 7.9 for C3. So what is the mean of this? We found out for each feature and each class we have found out. Standard deviation we have found out. What is the effective range? I showed you the formula. And then we sort the lower effective ranges, we find it. And then we find out, see, here 4.9 to 4.59 to 5.41. And then next one is 5.34 to 6.53. We find out how much is the overlap between the classes for feature 1. So then we find out the area coefficient, that is overlapping area divided by max of the upper minus mean of lower. Then we find out the area coefficient. Then normalized area coefficient we find out by dividing by the maximum of this area coefficient. Then we find out 1 minus 0.38, that is 0.62 is the feature weight for feature 1. Like this, we repeat for feature to find out the overlapping area. First, find out the effective ranges, sort the lower effective range, find out the overlapping area, area coefficient, normalized area coefficient, and find out 1 minus the normalized area coefficient gives the weight. It's very interesting to observe. Just see. Here 0.62 is the feature weight for feature 1. For feature 2, it is 0. For feature 3, it is 1. For feature 4, it is 1. So what does it show? That is, feature 3 and feature 4 are the most important features for classification for Fisher's iris data. That means feature 2 is the most unimportant. This method has clearly recognized that feature 2 is the most unimportant feature for classification. You don't even have to look at the values of the feature 2 at all. Then feature 1 comes next, and feature 3. I showed in this graph also that feature 1 and 2 do not distinguish between the classes at all. There's too much overlap rather. But feature 3 and feature 4 can distinguish the classes very clearly, and that is demonstrated using this technique rather, feature selection technique. Name any technique. We found out, in fact, when I worked in NIST at Maryland, then they have taken our algorithm, they are working on it, and none of the algorithms in the literature give these crisp weights at all. There is an algorithm called Relief F, which is very popular, but every time you run, you get different set of weights because you have to randomize the initially. But here nothing, you don't have to initialize anything. Automatically you get the feature weights between 0 and 1, and whichever is very unimportant, it gives a value of 0, and which is highly important, it gives a value of 1. If it is 0.62, it is kind of midway rather. It is neither important nor unimportant, something like. So this is remarkable because it works very well on any kind of data set. So this is the why this is very effective method for feature selection of any kind of data. And what is the thing is, it is distribution free and can be used for any data of pattern recognition, gives weights or importance for each feature. So that is the most important thing which we find here. And if you have any other questions, I would be very glad to answer rather. Yeah.
Yes, any question, please? Yes, Parthav Jha, I think you have raised your hand.
Hello.
Good morning, madam.
Good morning.
Madam, I am working in Agriculture University, Tirupati.
Yeah.
Can it be useful in gene identification of SSR markers, madam?
It is, please, there are two things here. This is, suppose you have several genes which are contributing to this. Suppose, see, in any kind of, we have worked on many gene expression data sets, like there's say 12,000 genes are there, okay?
Yeah, ma'am.
All the 12,000 genes would not contribute to effective classification. So we have found that out of 12,000, we can select the top 10% genes which are sufficient for classification. But gene identification and gene feature, selecting the important features, these are two different topics. It's not for gene identification. If you have, let's say, some other problem which many genes are involved, you want to select which genes are important, that it will do, but not identify the genes. These are two separate problems rather. But if you have in agriculture problem, there are problems where genes, many genes are involved like that, then you can select the important genes. It is possible.
Okay, ma'am. Thank you.
Yeah.
Yes. Any other question? So, madam, one thing is that I want to say that the feature selection is without distribution. How we can justify it?
No, that is, you don't need the distribution at all, right? Because the Kolmogorov's inequality is distribution free. What we have done is, suppose you have, let's say, 2,000 features are there. I will find, let's say, 3 classes are there. You want to find out the overlapping area and all that, and then you apply the Kolmogorov inequality. That is irrespective of any distribution.
Yeah.
This is valid rather.
Yeah,
You don't need the distribution at all, rather, in this
Yeah.
case.
So thank you. I think thank you very much for nice lecture, Dilbhai.
Thank you
Sir,
very much.
Thank you.
Thank you very much.
Yes.
Thank you. Thank you all.
So now in the Professor Reddy, you want to say something?
Thank you, madam. Thank you.
Yeah, thank you very much.
Yeah,
Thank you very much.
We came and delivered talk, so I'm very happy.
Thank you very much,
I'm
Mr. Reddy.
because Machapan is good morning.
Yeah, good morning, Professor. Can you hear me? Sorry, apologies for the delay.
Yeah. Then and because I'm sorry, because of some adjustment, because of Chapan Bhattacharya in the last minute, he dropped. Then I requested Madam and our colleagues, both the so two lectures are covered. So I'm happy. So I'm sorry about your delay for half an hour.
No,
So let's
no,
complete
that's
my
fine. That's perfectly fine. So it's too early in the morning for me. It's fine. So 4 o'clock you wake me up. So that
Okay. So,
you
yeah.
Yeah.
Okay. It is 11 by half an hour, so 11:30 we will take class. Okay. Thank you. Right, Malik, please chair the session.
Yes. So in this session we have the our last speaker and very eminent speaker, Professor Nachipan Subramaniam. He's a man of supply chain management and known throughout the world, and he is the recipient of various awards, and definitely we are very happy to engage him that he is going to deliver some talks in the area of the supply chain management of some marketing problems. So without taking much time, he is a good career. He started his journey from Madurai, India, and went to different parts of the world, and a lot of credits are in his favor. So without taking much time, I request Professor Nachivan Subramaniam to kindly illuminate the talk, give the talk. Thank you, please. I request you.
Yeah, thank you, Professor Malik, and thank you, Professor Reddy, for giving me this opportunity. I'm just trying to present my screen. So you can you see my screen, please?
No, not now. You only PPTs are not visible.
Right. So can you see that? No. Bit of just give me a minute. So I'm new to Google Meet, so
No problem. That's why we all learning. No?
so we normally use Zoom and Teams.
COVID-19.
Yeah. Just
Right side corner is present now, sir.
Can I present now?
Yes, sir. Present now in right side button is there, sir.
No,
Present
I
button.
did, I did. But only thing is I can't see. Okay, share.
For share, you need to click the screen, sir. The window, select the screen.
Yeah, I
The
did. I did a window. Okay, right. I did. So can you see now?
yes,
Can
sir.
you see?
Yes, sir.
Yes, sir.
Yeah. So, fine. Thank you so much for this great opportunity. I should thank Professor Reddy. I met him in Madurai for when he visited us for a conference in like I think late 2010 for a ORSI annual convention. So from there we are working like we know each other and things like that. So he requested me to give a talk today on this occasion to honor Professor C.R. Rao. I don't have much contact with Professor C.R. Rao, but I have heard about a lot of good things about Professor C.R. Rao. So I took this as an opportunity to share my recent research, but I am not showing going to show many numbers, but I'm going to share with you some of the research what we are trying to do in terms of post-COVID, like COVID or post-COVID scenario. What is going to be in the supply chain? For example, we are more interested in cargo transportation and logistics, how this is going to change, what are the challenges they do have right now, and how it has to dealt with. So I'm just going to throw some insights on what we did in terms of topic modeling, so which is a emerging technique to analyze the textual data. So we have a huge data sets in terms of various white papers, academic articles, and things like that. So we wanted to pull out and develop some kind of relationship between the challenges and solution, what people or experts discuss and then share their perception. So that is our aim in this study. So please stop me if you can't follow somewhere. So this is a bit of like a work I'm doing along with my colleague from Turkey. Her name is Yasunur, and she is working as a professor in Turkish German University. So the talk is like what solutions or what challenges right now we have, what we have seen from this COVID-19 pandemic, and how this has to be sorted out in the future, where the companies, especially logistics sector, need to focus. That's our aim in this talk. So we all know like there are a lot of debate on right now. So we talk about globalization, which was very good for many of us, like India, China, all emerged using this globalization. But right now, with these kind of natural disaster, like kind of a disease, which has shown the real impact of globalization. So what we are seeing is like in the natural setting, it worked very well. The lead time become longer for in the supply chain, but they're able to reduce cost. But now what they can see, like when there's a disruption, so they feel it is very bad. It has like a lot of people, like again, like for example, if you take UK, where I live right now, they talk more about Brexit, national protectionism. Whereas if you go to America, they say like America first, do everything within America, don't source anything from China. Things like that are going on right now. So there are uh, total changes. Now people in the Western economy realizing something is wrong with globalization. So globalization also showed that we are highly interdependent. So some countries become very rich, some countries become very poor. So we also found out like global supply chains lead like will not work in terms of like when there is an untoward incidents like natural disasters. It's very less safe, and it is also like we have seen now. Fortunately, the food supply chain is working pretty much good because of various safety measures. But it is susceptible to virus. It's very hard to treat. So that's what we are realizing right now. So previously, when like in 1990s in India, then they opened up the market to the global world. So they thought like, okay, for India there are many opportunity, as well as for the Western economy they wanted to save a lot of money. But if you make a trade-off in terms of whether cost saving is good or it is too expensive during these kind of disaster. Now all this Western economy realized that too much of cost saving will hurt them during kind of natural disaster. So that's a big learning right now for all the companies in Western economy. So we have seen the real face of product and service supply chains, and how it get disrupted when there is a natural or a man-made disaster. So in the past, for example, for a flood, tsunami, earthquake, and those kind of scenarios, global supply chain recovered pretty much fast. So every year, if you go to Latin America or North America, you can see a lot of floods like Katrina, Maria, things that they speak about a lot. For example, in India, we had in 2004 tsunami. So those during those times the impact was not much, but this time because of this COVID-19 there is a global impact. So there is a vicious cycle on there is an impact on both supply side as well as on demand side. So there are a huge spike in need of toilet papers and a lot of retail groceries and things like that, so which there is a panic buying on the from the customer side, whereas on the supply side there are a lot of challenges in shipping things from the global manufacturing based China to to the rest of the economy. So it really, when we see it as a vicious cycle where there is a huge spike in demand and supply, and they don't know how to come up with the mitigating like our coping mechanisms. What we learned in the past would help us or not. So that's what the issue right now we have. So now after all these happening like for like 6 months, like all the global countries are struggling how to keep up the supply chain alive and sustain it. So that is a big question. So that made us to think about like what we need to do. So like for example, we did a extensive analysis in terms of medical supply chain, especially what happened during COVID, the need of PPEs, need of gowns, need of gloves, need of ventilators, masks, and things like that. So, like especially from the Western economy, there was like shortage of PPE, shortage of quality masks, shortage of N95 masks, gloves, and a lot of other issues has been exposed during COVID-19. So we classified the challenges. So we did a topic. I will come to topic modeling a bit, which is an emerging technique, and most of you may know this technique. Uh, what we looked at is like we wanted to know what are the challenges on the supply side. They we call inbound challenges, and then we found out what is happening within the companies. Like for example, delivery. Like if you take Amazon or Flipkart or whatever you say, like Taobao in China or eBay. So, what are the challenges, operation challenges they do have, and what are the outbound challenges on the demand side? So, in terms of inbound supply side, we found out there is a lot of capacity reduction due to the safe distancing and sanitizing and staying away from people, things like that. So the spread of virus, which is still misery, like how it spreads from one to one. So that reduced the capacity in the all the companies. Warehouses are overloaded because they can't ship exactly on time, and then like there is no space, and then there is a downturn like in freight demand, so people don't buy, like they don't spend like in the past, and there is a visibility lack of. This is a big issue. So for example, supply side, they don't know, like again it happened in a cycles. So first it happened in China, then it moved to the epicenter moved to Europe, then the epicenter moved to the US. So it went on like a pattern, like a shifted on a sequence. So everyone, when they got, they took some time to recover, then they have to supply. So that's what happened. So there is a lot of lack of control, and then the cost also shooted up. For example, because of all this extra safety measures. In terms of operational, like big mess in schedules, capacity issues, and then there is a deferred slowdown in the movement of goods during operation of logistics processes. Again, there is a new kind of regulations in terms of safety and hygiene of the product they are trying to ship from one country to another country, and the shortage of drivers. People are scary to do this job because they were afraid of their life. So it's very hard to find out people. There are a lot of self quarantine rules and things for different countries at different norms, and especially the country who learned very well, for example, New Zealand, Finland, those countries are very good in terms of coming out of the appropriate measures in place to restrict the spread of this virus. So border restriction control, like as I said, like the countries were very, very good at one point of time. Like Vietnam, for till now, like we can find only one case. They did something good. We don't know exactly. So we wanted to find out what it is. So, in terms of outbound challenges, there are a lot of delays. Lost cargo, many lost their cargo. Uh, they have to hire people and train them. So there was no skilled labor to do these kind of jobs. Uh, so again, the Amazon Prime, they can't keep up with the 1 day delivery, and then they have to think about other options. There are a lot of visibility issue which is for flagging up both on inbound supply as well as demand side. And in terms of like technological the companies who are very well like able to adapt new technologies survived better, and then others struggled a bit to learn and migrate to different technology. So, in terms of what we did exactly, so what I have given is a context why we want to do this study. Typically, what are the issues we had during COVID-19 in terms of logistics, from on supply side, operation side, and demand side. So, what we did exactly in terms of research to find out the short-term challenges, the challenges, and classified them as a short-term, long-term, and what kind of solutions could address those short-term and long-term challenges. So, topic modeling is a blue ocean topic. It will be used to identify some of the challenges and solution in a blue sky kind of a research where we don't have a previous study. So we do have a lot of studies on natural disaster, the supply chain disruption, supply chain resilience, how to build capacity, and things like that. But we don't know exactly kind of these kind of pandemics. So pandemic happened, Spanish flu happened in early 19th century, but we don't have much literature available in terms of how to deal with that, the supply chain which are globalized. So that's an idea. So we wanted to use a topic modeling. Then we collected an empirical evidence. We spoke to few logistics managers globally and try to identify what they face and what is needed. So, bit of numbers. I am not showing a lot of numbers here. So, the topic modeling is a method which is very popular recently for text mining. So, we selected number of topics. We included number of words in the document, and then we did this analysis. We had like 400, 500 documents, which is like filtered documents to analyze the words and see like which is appearing again, which is this is not like a word cloud. This gives a relationship between solutions and kind of a challenges. So we found we need to set the various parameters. Alpha is a distribution of topics per document, which gives beta as a parameter of distribution of words per topic, and this is like phi is like a word distribution for topic, for a single topic within for the whole set of documents. So likewise, we selected these parameters for this study. So there are four steps involved in this topic modeling. So we collected the data, then the documents, then we selected the documents and we prepared the document, and then we did the analysis to find out the connection between challenges and solution, and what intervention should be made in order to overcome this. So I'll try to run through all the four stages. Like the first one, in document collection, we prepared strings, and then we determined data sets. For example, we collected all sources because of limited availability of literature. We included internet all blogs, consulting report from major companies like McKinsey, Deloitte, and things like that. And then we also they call white papers there. And then we included all the academic studies. I don't know, like recently all the COVID papers were very, very fancy to publish in journals. So they were very keen to publish something to increase their impact. So we collected all those papers and we set a time period. For example, um, we use search string like COVID-19, post-COVID, COVID-19, post-corona, coronavirus, and things like that. And then the time period we set as January, from where it started in Wuhan until now. So we stopped at August because we consider only the first wave, so that what we want to understand what happened. So in right now in the European countries, we are in lockdown right now, and then it is second wave is on, and then the spread is enormous. So our rate is more than one. Data set, we included internet sources such as a news site, as I mentioned, blogs, survey for social media channel, consulting report. We included magazine article, white papers. From academic papers, we used all this popular databases like Science Direct, Web of Science, Taylor and Francis, Google Scholar. So in total, we collected 628 relevant documents through a search engine, then 30 consulting report and 18 academic papers. So this is the first step we did to understand, for us to understand what is happening. So in the second step, what we did is looked at this title abstract, and then based on that we made sure that there is no duplication, and then we looked at the introduction and conclusion based, and then we excluded few documents, and then we read the full documents, and then we selected the primary documents. So we found out 292 relevant text documents from internet sources, 24 for consulting and 15 from academic papers. So we listed, you can see a sample there. In step three, in document preparation for analysis for topic modeling. So the text list of stop words, like for example and, period, etc. We all removed those in the analysis. Then we did a Python based modeling program. We used LDA mallet to analyze the text document. The words are trained with 100 iterations. Some words are combined or totally executed from analysis if they have no meaning for the research. So we found out 9 possible topics with respect to. So we classified them into immediate challenge and long-term challenge, and we derived 6 themes. In the last, when we did the analysis, we ran the topic modeling, remove unnecessary words. Then we found out 6 themes. For example, operational efficiency, delivery performance, safety issues, supply chain vulnerability, shortage of manpower, digital gap, and thematic. So these are the 6 emerging. We see like everybody spoke about this one, like operational inefficiency. Everybody was started using more on lean, just in time, things like that. So they got struggled when when there is a discontinuity in supply. So we found out like these 6 issues are prominent right now: delivery performance, safety issue, vulnerability, digital technology support, and supply chain force. Then from the analysis, we went to the managers, like all the leading companies managers, and then we prepared a semi-structured questionnaire, and then we included 10 participants in our study from cargo, transportation, and logistics industry. So those were from Germany, Austria, Italy, UK, and Turkey. Mostly it's a medium and large companies like DHL, FedEx, and things like that. So the average experience of the managers are very highly skilled people, like 19 to 20 years of experience they had. So what we found out, like out we as I mentioned, like there are 6 in the left hand side. You can see like 6 challenges, and then we found out some of the solutions from the analysis. Like they talk about sustainability, resilience, digitalization, collaboration, end-to-end visibility. Still now, in the terms of distribution of vaccine, they are thinking how to. So in the advanced economy, for example, Europe, like there is no effective coordination between countries to distribute vaccine to the needy people. So bit of like issues with coordination. So we talked about the solution should be collaboration, end-to-end visibility, and we also found out what people spoke in terms of how to mitigate these kind of challenges. So we got intervention. So our idea basically is to develop a framework based on living change model. So to find out like what things the companies need to unfreeze immediately, what needs to be changed in short term and long term, and how to refreeze, how to come up with a new resilient supply chain network which can stay for any, which can withstand or sustain any kind of disruptions in future. So that is our aim. So we are working on this is a working paper, and then we are working on this model right now in terms of come out with some kind of theoretical propositions. based on this study. So some I will try to highlight some of the challenges we found out in terms of operational efficiency, inventory accuracy, demand forecasting accuracy, cooperation I mentioned. So capacity optimization. These are immediate things people need to think about in terms of like with the COVID measures. So we need to take into COVID safety measures when we try. So what in the past, our aim was to reduce costs and things like that. But now the COVID measures also need to be considered. So in future, like how to make our supply chains more robust, like it is based on intermodal transportation in terms of integrating customer behavior. For example, if there is a panic buying, so what people have predicted in next in the future, in every 4 years there is going to be some kind of disruption or disaster, one way or other. So how to get prepared for those things, so that is what our aim is to understand. So we wanted to have a new business model and services. So likewise, in terms of delivery performance, we need to have flexible warehousing. We need to have a green transportation and logistics practices. We need to have more logistics intelligent data analytics. We need to go for like smart distribution centers. What they do have in Western economy for Amazon, Okado, they do a very good like automated warehousings. How to bring in the safe cargo corridors, smart ports and terminals and things like that. In terms of workforce, we need to have some kind of capacity in terms of not in terms of goods, in terms of manpower. How to work with public private partnership works pretty much very good, rather than going for like public or private. So like local knowledge is important to deal with these kind of pandemics. uh, then how to deal with real time disruption alerts. uh, how to make sure that there is a good workplace safety training program, hazard communication, what we do. So these things are important in future to make. So I have few more videos, but in the interest of time, I'll try to cut short my presentation in terms of highlighting what we are working on. So in terms of digital technology, this is paramount important. Like when you see in supply chain, they talk more about digital technologies right now. That has helping us to connect. For example, I can talk to you through a good use of like Zoom or Google Meet or any technology. So in future, like all companies need to invest on digital supply chain platforms, which is a kind of a safety aspect, plus also they need to evolve and adapt to the changes. And they can monitor, track at pallet level, and then there will be good visibility so that people can't blame something is not known for others. And for example, they are using pretty much blockchains right now. And then the technology could also help companies to sense and demand they shape the demands. So, in the interest of time, so try to conclude. So, this is an ongoing working paper. My main focus to share with you is to show about the use of topic modeling for a blue ocean topics, where we don't have abundant literature. So that's what we engaged this method, and then I wanted to share the method, how it worked, and what we are trying to find out. So we what there were good lessons learned from COVID-19, which triggered large problems for many companies. There is a lot of loss of income. We know very well, pretty much hospitality sector, retail sector, aerospace, every automotive all got hit. And then the supply chain got totally global supply chain got disrupted, and there are like a lot of uncertainty. So there is like a lot of problem, then there is a lot of opportunity. So there is like all companies are learning how to overcome this in future. So they are getting prepared now, the good lessons they have learned right now. So I think there is no I can't come we can't conclude here based on the study that one size strategy fits for all. So there is like different kind of issues, different solutions are needed, which is an ongoing emerging research topic for academics, for us to solve and contribute to this, to come up with a good solution so that we can make the world, the future world very better. So with this, I'll stop my presentation, and I'm happy to take your questions. Thank you so much.
Yes, any question from the audience? Yes, Nachi Subramanyam, I have some discussion with you.
Yeah.
Actually, all we are facing the COVID-19 pandemic situation since last 1 years.
Yeah.
Do you think that the transportation problems and some logistic problems will be restored in the coming days? And how it will take? How much time it will take?
Yeah, that is good. Like it will like so people now there are bit of debate in terms of vaccines could cure and we will return to normal, but again we need to take into account the safety measures and we need to be a bit proactive. So in next 3 4, like in summer, like they say April May, we will return to normal life, but still the transportation problems need to take into account the COVID measures like safeties, like distance, like the handling of products and things like the delay in times of delivery. Those things has to be taken into account. So the parameters of distance, safety need to be included in a transportation problem. So there are like for scheduling, we need to include like safety aspects in scheduling. So previously we look at the resources only in terms of availability and kind of capacity and things like that. So but now we need to think about more about safety, and some kind of virus it reoccurs or reappears, like how to overcome that.
That again in the UK and some European countries are second waves is going on.
Yeah. So there are a lot of research from us, from academics, need to be done, like how to change this conventional models like assignment model, transportation, VRP model. So how to include this say COVID measures into it. That is a big opportunity for us.
But the beauty for all of us is that we all now mentally prepared to
Yeah,
face the
yeah,
problem.
that's true. That's true. Yes, yes.
So, any other question from query? Okay, so really very thought-provoking lecture delivered by Nachum Subramaniam.
Yeah,
So we hope that all these measures are required on the part of the government as well as on the part of the management sectors, so that
yeah,
we can get out from this such type of pandemic problems. So thank you very
yeah.
much, Professor Nachi Subramaniam, for
Thank you
delivering.
so much. Thank you
So
so much.
I hand over the session
Yeah,
to.
thank you, Nachapan. Thank you for your nice presentation. And now I'm thanks to our chair, Malik, for yeah. So I'm happy to the next session because of running time. So the next session which we are going to start. The next session is chairing is Professor A. Ramakrishna Rao, and the other two speakers, Professor Pradeep Kumar Roy. He is from Dean, Vinod Gupta School of Management, IIT Kharagpur, and the other one is from Professor Ravi Narayan Subudhi from Bhubaneswar, KIT School of Management, Bhubaneswar. So now I am happy to introduce Professor A. Ramakrishna Rao. Professor Ramakrishna Rao is now currently is a director for Sri Padmavati Mahila Vishwavidyalaya Engineering School. Um, yeah, he did his BE, ME from Venkateswara University, Tirupati, and later he did his PhD in Institute of Technology, Kharagpur, India. Um, after that, he joined. After that, so that he is having published in the area of fertilization, mechanical, industrial engineering, operational research, operations management, and a number of for 33 publications which he has done it, and presentations also 38. He has supervised 7 PhDs and 51 MTech dissertations he has guided, and he has organized 5 workshops, and a number of this one is attended to more than 20, and he has completed 2 major research projects, and he has worked more than 37 years teaching experience at the university level. So he was also the Dean of Engineering and the Principal of SP University, Tirupati. So now I request Professor A. Ramakrishna Rao Garu to chair the session. Thank you.
Sir, please unmute your mic, sir.
Sir, please unmute Ramakrishna Garu. Yeah, unmute your mic.
Okay,
Yeah.
Mr. Rajsekhar,
Okay.
do you hear me?
Yeah, yes. It is good.
Good morning to all of you. I'm really happy that a massive conference is being organized by the War Society and the statistics people on the occasion of the 100 years of a great statistician, Professor C.R.RAO. I'll straight away come to the topic. Today, we have two eminent scholars giving their presentation. First one is Professor Pradeep Kumar Ray from the AWARDEE Kharagpur. I think Professor Ray is seen to me. Okay, am I visible to you, Professor Ray?
Yeah.
Professor.
Okay. Then.
Ray.
Good morning to all of you.
Good morning. Good morning. Do you recollect?
Yes.
Yes.
Hello.
Hello. Right. I would like to have a brief introduction of Professor Ray for the members. And Professor Ray's introduction goes to number of pages, so I won't be able to put all that, but in a very brief nutshell, I would like to introduce Professor P.K. Ray. Professor P.K. Ray is currently the Dean of VGSOM, that is Vinod Gupta School of Management, started by the Industrial Engineering Department of IIT. And he is the professor and in the Department of Industrial Engineering, Industrial and Systems Institute at Indian Institute of Technology, Kharagpur. He served as the head of the department in 2006 to 2009, received his PhD in 1991 in the area of productivity engineering from IIT Kharagpur, MTech from IIT Kharagpur in 1981, and BE Mechanical Engineering in 1979 from Shibu. He served in the industry for more than 8 years in the General Electric Company at Calcutta, then joined IIT Kharagpur. Professor Ray is originally started his PhD work in the area of productivity, that is operations management area, and specialization in productivity engineering. And he has done extensive work in the area of operations management, quality management, quality systems, and JIT Kanban systems, and productivity and optimization areas. Apart from being a pure functional aspect, he has moved to the application areas, and I find that his application areas included healthcare systems. He has actually moved recently to healthcare management. So his contribution in the area of healthcare is very, very significant, and we'll be listening to him shortly. He is also an expert in the area of quality control. He is a certified lead assessor for ISO 9000 registration and actively involved in a number of industrial consultancy and research projects. He is a member of several professional bodies such as INFORMS, IIMM, Indian Institute of Materials Management perhaps, a fellow of World Academy of Productivity Service Sciences, and a fellow of Institute of Engineers, and chairman, Production Engineering Division of its West Bengal State Center. He is a recipient of PC Mahalnabis Award of Operational Research Society of India for his outstanding contribution in the field of engineering. So I welcome Professor Pradeep Kumar Ray to make a presentation, his presentation for the benefit of all of us. Professor Ray, it's your turn. Thank you.
Thank you, Professor A. Ramakrishna Rao.
Yes.
And Professor Venkatesh Sharan. It's my pleasure, it's my privilege, it's my honor that I have been invited to give a lecture on my area of interest. But before I start my lecture session, I want to pay my, the respect and tribute to Vibhushan Professor C.R.RAO, considered to be a doyen of the statistics, and we are all, very fortunate that such an academic has he has been with us, and he is the person who shaped the growth of mathematical statistics in the 20th century, and he is instrumental in setting up our national statistical framework. Many distinguished academics are monitored by him and recipient of countless awards and accolades. So my, this particular, we are very happy that such a webinar has been arranged in great academic. Now coming to this part, like say this particular webinar is being organized by Operation Research Society of India, Tirupati chapter. And again, when you talk about operations research, so like say we pay respect to the persons like, the Liverman or say Russell-Ackoff, remembering them all the time, their contributions, Kattaji Murthy. There are many, many such, the great academics and researchers. And we are all aware of the contributions of operation research and the contribution of, what we can say that the Department of Statistics and the Mathematics in developing, a true the mindset, analytical mindset. That's very, very important, in fact, throughout the world. And I am thankful to the organizers for the organizing such an important the webinar, and I must be thankful to all of you for inviting me. Now coming to I will be taking around 45 minutes time, okay, for completing my presentations, my lecture sessions. As you are all aware of that my the presentation topic is award-based approaches for healthcare systems performance improvements. Few examples or few applications I want to discuss, and there are reasons for this one, that why I have chosen this the applications, award-based approaches in healthcare sectors. Okay, so let me just share my presentation material to all of you. Okay. Okay, so I hope that all of you can see my presentation slides. Hello, it's visible? Hello?
Yes, sir.
Okay, okay, thank you. Okay, so as I have told you that in this particular the lecture session, I will be highlighting a few award-based approaches for healthcare system performance improvement. Now, let me make some introductory remarks. Like say, you're all aware of that in a country like so the India, who is considered to be a welfare state, obviously the healthcare sector, becomes one of the most important, say, the service sectors in any country, in fact. And as what was the status of healthcare sector when we got freedom in 1947? you're all aware of, in fact, there had been hardly any healthcare systems in India in 1947. You know that the child mortality rate was around 25%. It's very, very high. And over the years, now it has come down to less than 1%. Okay, that's a great achievement for a country like India, our country, with 135 crore population size. So it's a great achievement, in fact. So the healthcare system, but however, you will find that there are many stakeholders in the healthcare sectors, and the healthcare system is very, very complex, involving large number of stakeholders with diversified requirements and coupled with resource constraints in the socio-technical context. So, the modeling, what you try to do, that means when I say it's an application, essentially, the empirical research is a must. The database, the modeling is a must. So we have carried out, and our problems are very, very unique, in fact. Fine. And what we have noticed that unless and until you go for the field study and the database modeling, the problems are never addressed. And in many time, what happens that instead of addressing the primary problems, we may harping on the secondary or tertiary problems. Now, the performance of healthcare system in India needs to be continuously improved. I am saying that definitely compared to many, many countries in the world, our performance is excellent, in fact. But then again, we believe in the concept of continuous improvement. So, what we try to do, there are three important aspects. One is definitely the the reachability or the access. The second one is the affordability, and the third one is the quality. So, a number of critical issues affecting the performance of Indian healthcare systems have been addressed with the objective of designing a comprehensive framework for healthcare performance improvements. Okay, it has to be a comprehensive framework. And as you may be knowing, the WHO, with respect to any country, they have said that the first thing you should concentrate ability, you must have ability to become accessible to the entire population of a nation. Ours is a nation, so the first thing is the availability, make sure. Second one is very, very important, like ability to become affordable by the entire population. That is the affordability. And the third one is ability to provide quality services to all the stakeholders. That's referred to as the quality. Now, what we have found that as far as Indian system is concerned, healthcare sector is concerned, these are the few important research issues. That means there are many problems we find, and as such, you know, at different quarters, maybe many of these problems are referred to as unsolvable problems. So, as a researcher, we must take up all these the so-called unsolvable problems, or say the non-routine problems. So, when I classify these research issues, the five important issues, becoming very, very crucial. One is the resource scheduling. Second one is the economies of scale. Third one is the hospital inventory management. Okay, you are all aware of, in fact, if the inventory management is good, it will have a direct impact on the cost as well as in the price. So the waste management is an important area, and of course, an important research areas is networking. So as far as the HC availability is concerned, so what you try to do, I've identified several areas like development of geospatial healthcare data models. That is one. Modeling disease spread networks. This is also have found that this is very, very important. The many young researchers, they should concentrate on this particular research area. And epidemiological modeling of disease patterns to identify geospatial, temporal, demographic, and socio-economic causes of diseases. This is very important in and the capacity planning for healthcare infrastructure. So these are the other issues, in fact. like
Excuse me.
optimal locations, framework for public-private partnerships, and the development of distribution cloud framework for storage, maintenance, and update of patients' demographics. It's very important for a country like ours, in fact, like as a heterogeneous the population.
Sir, excuse me,
And okay, and the medical,
sir,
and so what do you need to do? Hello,
sir, we are not able to see your PPT, sir.
you can't see for
Yes, sir.
PPTs? How?
Okay, your screen is presented, sir, but not able to see your PPT.
Okay. So, but the first, the first slide was seen, no?
No, sir, just we got your Google Meet screen.
So I verified. Sorry, I don't know. Can you see this slide?
Yeah, now we are able to see, sir.
Now,
You can
okay.
see it?
Yeah, yes, sir.
Okay, fine. So now suppose the next one. Can you see it? This one. Okay. Hello.
Yes, sir,
Hello.
okay.
Okay then. Fine. So right now there are different dimensions. Okay. So okay, fine. So there are three important dimensions. So the first dimension is definitely the availability, and under availability there are many research issues or the research problems. We need to, first we need to identify in a given context which one becomes a priority, and then definitely we should work on that particular area. Is it okay? So the first one is definitely the availability. Sometimes this is referred to as the access. The second one is the affordability. This is very important, as I have already mentioned that ours is a welfare state. Okay, it's not a business entity, so it's a welfare state. So obviously you need to look into the interests of everyone. That means the people at all strata of the society, and that's a very challenging assignment, in fact. And so the next question is affordability. Analysis of geospatial attributes and the
Okay, sir.
temporal data. Okay, so these are the areas I have already mentioned in fact, and the classification, optimal scheduling of healthcare resources. As you may be knowing that, because of historical reasons and others.
Sir, excuse
So,
me, sir.
yes, yeah, what happened?
Sir, slide is not moving. The first
How
slide.
can it be in fact? What happened? Let me try.
So click on that
We,
slide show.
we have been doing it for the same system for other webinars also. Yesterday I did. In fact, there was no problem. The same system we are following. I don't know.
Slideshow screen has to be done.
As far as our knowledge goes, at our end, we're unable to find out the fault at this point in time where we have gone wrong. It's okay. It's all right.
Yes, sir, no
Everyone
press.
can. Okay, next one. Just let me, first verify. Okay, okay. Next one. Can you see?
Yes, sir, we are
Hello.
able to screen, sir. First slide.
First slide.
No, the first slide. Okay, this one. Can you see it?
No,
Yes,
sir,
sir.
the slide is not moving, sir. It is in the first one.
How can it be in fact moving? Using yeah. Is it uncontrollable noise factors? No. Hopefully you're able to find out. Share, share. Again, let me try once again. Huh?
Okay.
Sorry, don't know. With the system we are following, the same systems we have been doing for the last couple of months. Okay, whenever we join webinar, giving lectures. Can you hear me, Professor?
Yes, sir.
Okay. Okay. Now let me share share my presentation materials. Can you see it now? Hello.
Yes, sir. Yes, sir.
Okay. Okay. So the next one. Suppose I change it. Yeah. Can you see it?
Yes, sir. Yes, sir.
Okay, okay, fine, fine. So, okay, thank you. So, the second important aspect is affordability. You can see it, no? Okay?
Yes.
Hello?
Yes. Yes, sir.
Okay, okay, fine. So, so the second important aspect is affordability. That's a very important one as far as our the country's interests are concerned. In fact, okay, and the kinds of social systems we have, and when we say that it is a welfare state, okay. So there is the healthcare affordability. There is an important point, in fact, and what is most important is the development of appropriate economic pricing models for different kinds of services. This is the key issue, in fact, and development of effective referral system for patient-centric services. Because ultimately, whenever you talk about the healthcare systems, everything is must be geared to the serve the interest of the patients only. Okay, so the last one is very important. That is the HC quality, and that's basically but the sufficient condition. But we need to meet the necessary condition first, and then we can talk about it. Will be easier for you to have quality in the healthcare services. So the healthcare quality management systems, development of performance measurement evaluation schemes for different kinds of services, and development of socio-technical system models for healthcare system design. And the last one, right now, we have been carrying out a project, in fact, particularly, the interface designing. It's very important, and these are referred to as ergonomics or human factors engineering-based design, interface design between the, for the healthcare personnel, in fact, service providers. Okay, so these are many other issues, in fact, like the safety management systems, medical waste management, and the decision support systems. Decision support systems we have been working on. So, so if you try to implement, there are many dedicated persons. They have been, they implementing all these systems, and they're on the job day in and day out. Hats off to them. So development of models for prediction and optimization. So disease patterns, patient flows. We have carried out, the research on the patient flows, the resource mobilization, staff and appointment scheduling, inventories. We have carried out a number of research work on inventory management systems. Okay, so these are the issues. In fact, healthcare performance management systems, these are all interrelated. Healthcare inventory management systems, quality management systems, waste management systems, safety management systems, and the decision support systems. Okay, so so there has to be an integrated approach. So I will just highlight few important research areas and corresponding the research framework. Because of shortage of time, I have all the details. In fact, I cannot explain all this. The first one is one of the important areas where we have worked. That is the patient appointment scheduling. Is it okay? This is one area, and this sort of the research framework you can definitely adopt. The second one is the healthcare performance management systems. There are many stakeholders, and so what do you try to do? In fact, not only you are meeting the needs of the patients, as you may be knowing, for the service organizations, both needs as well as the wants you know, uh, you have to satisfy, and that too, the interest of say the person at the individual level, the patient, that is most important, in fact. So as such, what we have observed that someone calculates the average, the performance level, it doesn't have any meaning, in fact. So, the perception of, the patients, how it develops. Okay, that's also very important aspects, in fact. What is the perception of a patient vis-a-vis a privately run hospital system? What is the perception of a patient vis-a-vis a government-run hospital systems with respect to a specific, say the aspect of the service. Is it okay? So this is very important one. Now, healthcare inventory management system, just two were the models I'm going to discuss on this, and then you will come to know that how the inventory management system is directly affecting the cost of treatment. And that is a general, the perception of the people throughout India, that the cost of treatment, there could be some exceptions. If you go to a private, a privately run hospital system, whatever may be the reasons, okay, but ultimately the patient's perception is the cost of treatment is very high and you have to pay heavy price. Is it okay? It may not be affordable in majority of the cases. So these are the, the approaches we have to follow when you take up healthcare inventory management systems problem. Next one is the occupational health of healthcare personnel. Many a time what happens, the patient will be tested. Is it patient condition will be tested. Now, its exposure time is very less. So the risk is less. Is it okay for the patient? But then again, for the what about the healthcare personnel? Okay, their exposure time is more, and ultimately, what is happening in many cases that healthcare personnel are becoming sick. So this is a very important area, in fact, as you may be knowing, that not only for the service sectors, even from manufacturing sectors, production systems, chemical plants, everywhere, you'll find that the occupational health is, the monitoring and control. It's a very important issue these days. So this is one. Biomechanical evaluation of patient handling jobs. That is another area. Okay, and blood bank management for a country like ours. So it's a challenging issues, and as you may be knowing, that many of these problems they're not even forget about problem under certainty, or even they're not problem under risk. They're all problem under the uncertainty, the Carl Pearson systems of equation. Okay, so that's and many sorts of approaches are basically non-parametric approaches. Parametric approaches, when you deal with, say there's a small sample size, is it okay? So many a time, no, you have to the specific situations you have, the mathematical, the parametric approaches may not be applicable. So the blood bank management, right now we are carrying out a research work on this, the blood bank management systems, and you'll be astonished to know that how interesting the problem is. Is it okay? And when you try to model it, the problem under uncertainty, the many sorts of, the you will have the in-depth understanding of the problem. So that's we are dealing with word-based modeling. The main advantage is as a researcher, we developed in-depth knowledge. So these are the the concluding remarks, in fact, on all these issues. Okay, like say implementation of the framework in a phased manner that we have to do. Is it okay? Now, why should we now just out of the many issues, research issues I have pointed out, the time is very, very short. So I like to highlight, certain the research, the problems that we have taken up. Okay, we have addressed. Okay, uh, and those two problems are related to inventory management systems. So certain data should be aware of. It is the fastest growing sector service, complex system, diversified requirements, affordability, accessibility, and quality. Global spending on medicines per hospital increased by 18.5% between 2015 and 2017. This data up to 2017. And you have to check this data. That's another problem we face. So many sorts of data you get. Okay. But then you have to verify this data. Is it okay? So that's another very important issue these days, particularly for the researchers. 21% hospital pharmacies experience shortages. So we have overstocking and simultaneously we have understocking. And many of these medicines are totally controlled by the foreign suppliers. That means we are dependent on, the imports. Is it okay? And if you study the price levels and all, you'll find there are the problem of, or say the process of procurement is so complex and all. There are many parties involved, there are many control points, but ultimately, as when you talk about the quality of performance, ultimately, you are always at the receiving end. The shortages they lead to delay of patient care 80%, increase in healthcare cost 98%, medical safety issues or error 89%, inventory cost 20% of the treatment costs. Okay, so do you have control on this? And India ranks 145th positions out of 195 countries. So this is the classification. I don't need to elaborate on this. You're already aware of, in fact. So here it is expendable items and the non-expendable items. Is it okay? So as far as healthcare system is concerned, this is the classifications you have to do, as you are all aware of, in fact, that you have to classify first the classification, and then only the data to be appropriately classified from different perspectives. So these are the problems and research issues, like the continuous change in patient medical condition, variability in length of stay, variability in care units, heterogeneity. This is another problem we have. The demand dependence among items. It's a very complex scenario, and you have to do this. Otherwise, the model with some assumptions may not be at all applicable. Okay, you cannot validate those models, in fact. So these are the research issues. So first is you have to get the patient information, and uh, and due to rise in individual preference of physicians and dynamics in physicians prescribing behavior. So this part we have taken up, in fact, the physicians prescribing behavior. Is it okay? So what sort of the modeling we have? In fact, uh, the Markov processes are applicable in this case. In fact, the semi-Markov processes. Suitable models for discovering hidden patterns in prescription data is required, and that we have done, in fact. An assessment of stock out cost is essential, as it leads to fatal consequences. That means basically it's not even no chance of having back ordering, but it's a lost sales case, in fact. Affordable healthcare systems, the demand dependence. Okay, so these are the research questions we have already. I have told you all these research questions. These are the drafted in a different format. Research questions. Does correlating patient condition, that is very important, in fact, with demand, improve parts? Now the improve performance of the healthcare inventory management system. Now, the medical, the science has improved like, enormously over the years, in fact. What is the advantage is today, you name any disease. Now, definitely the medical personnel will tell you about how many different stages it may have. Getting my point? Like say almost all the diseases. This is a great achievement, in fact, this knowledge. Now, what has happened? But this condition, the patient condition, is it okay? So suppose he is in the first condition. What is the probability that he or she may go to the next stage? Also, suppose there are n number of stages we have. N stage is the last stage on one. That means after, if you cannot control this stage, that means you are going to blue. So that sort of situation. Now, obviously, the stage wise, the stage wise, you have the medicines. You have the medicines. Now, what we have studied, we have studied many hospital systems. In fact, these inventory control systems they are not aware of all these issues, in fact. And even if the doctors are aware, but then they do not know about the inventory management systems. Are you getting my point? So the persons who are in charge of the inventory control systems, of the storing and all, they are not aware of all these details. Whereas the doctors are aware of the stages of a particular disease, and the corresponding the requirements of the medicines at different stages. But then again, this information is not known to the persons who are in charge of the inventory control system. So second important issues we have studied, in fact, that is physicians prescribing behavior affect performance of healthcare inventory management systems. Uh, what we have done, basically, development of a stochastic model. Obviously, it has to be a stochastic model for optimizing patient condition-based inventory control systems for healthcare items. considering patient illness, their treatment stages, and the type of care units. And examination of the second important issue is examination of role of physicians in inventory management system and development of an inventory control model considering dynamics in physicians prescribing behavior. So these are the two areas to highlight, in fact. So these are the critical appraisals, like we do review of literature and all. So I can skip this part. And this is the, the research framework we always follow. First one is the data collection and analysis phase. The second one is the modeling phase. And the third one, obviously, you are all aware of, verification and validation phase. And then only we can talk about the implementation phase. So implementation is an absolutely different ball game. Even during implementation phase, what we have noticed, there are many kinds of research issues. That's a challenge one. Definitely, those are the challenging, the problems we come across. But we have to follow in a step-by-step approach and slow but steady. So this is just one application. I just want to highlight that how we have modeled it, in fact. Just one examples, patient condition-based healthcare inventory control systems, and the kinds of, the models we have proposed, these are all can be considered as a generic model. Okay, so application one, first one is demand estimations we have to do, dynamic, say the replenishment decisions. Okay, so these are all well known to you who has gone through a course on inventory, inventory control systems, theory and practices. So there are many textbooks on this one. There are many case studies. So I presume that whenever you take up this particular problem, he or she must have a thorough knowledge in the inventory control systems. Patient condition, so illness, then the treatment stages, as I've already told you, these are known. Okay, type of care units, these are also known. And so that means it is basically the problem under certainties is an advantage we have. Consumption of medicines and other healthcare items. This data you have to collect. Complexities, uncertainty regarding patient condition while hospitalized. Is it okay? This is all probabilistic. Whether someone may go to the next stage, or someone may come back from the earlier stage to the previous, come back to the previous stage. That means the treatment becomes effective. Or sometimes no, a patient may continue with the same at the same stage, okay, for extended time period of time. Is it okay? So correlation between patient condition and the demand for items. So it's a non-stationary demand. Okay, so you're all aware of what is a stationary demand, non-stationary demand. So this is the flow diagram. Okay, the treatment stage one, this you have to specify given a particular disease, and the patient discharge or the death. That's ultimate. Okay, so even if you reach here, you may be discharged. That means your treatment is effective, or you may go to the blue. So the medication demand, this way we have collected data, treatment stage one, care unit one. So this is, and the algorithm accordingly, you have to suggest the algorithm. Okay. So this is the problem setting. The patient receives the prescribed items and end of planning horizon, capital T. So this way, the states of the systems you have to define, the inventory level and the patient condition based demand process. Okay, so this is the problem description, right? So all the important, the parameters, the variables, responses, the tools and techniques to be used at different stages, all these to be prescribed. So obviously there will be many kinds of notations we need to use. Hello, you can see it or no? Hello? Hello, please. Hello?
Sir?
Yeah, you
Yes,
can
sir.
see
It
it.
is visible,
Okay,
sir.
okay, fine.
Yeah, it is visible, sir.
Okay. Okay, so the model formulations, this is the model formulation, right? So I've already mentioned that it's a very complex system. So looking at this, the formulation, you can get an idea that how complex the problem is, in fact. And so the stochastic dynamic programming Markov decision process. So I presume that many of you are aware of all this one. So these are the constraints in the capacity constraints, service level constraints, finite planning horizon, Okay, so that is to be decided, obviously. Okay, the planning horizon determination is very, very important. In fact, now we have to search for the solution approaches. So the backward induction algorithm is found to be an applicable, the solution approach in this case. So all these details we have given over here. So this is a case study. Once the modeling is done, we have studied their systems, and then they try to have a best possible the model formulation or the problem, or you can say the formulation of the problem. So the first you have to formulate the problem, and then the dimensions of the problem, and then you have to search for the solutions, and then obviously you have to go for first verification, and then definitely the validation. So these are this is one case study we have done, in fact. So the preliminary understanding, this is very important, in fact. Data collection, and then only your the data collection process will be acceptable. So data collection and pre-processing, you have to process the data analysis, and the last one is the model translation. So is it okay? So these are the data we have, right? So with the state transition probability, these are all there, in fact. Okay, so all these parameters, divine characteristics, specific condition states, all these are here, in fact, and these are the results and the findings. So you have to interpret this one. Okay, and one policy we have tested, that is small s capital S policy. I presume that you are all aware of this. There are different kinds of inventory policies. So you have to check with all the different policies which are the feasible alternatives, and obviously you have to go for the sensitive data analysis. So the which parameter actually is most critical to control. Okay, so this is the sensitivity analysis we have carried out. So these are the conclusions. For stationary demand, order without considering change in patient conditions. Fine. Non-stationary demand, state dependent. This policy you have to adopt. And patient condition based inventory model is an effective solution to healthcare inventory problems, mainly the overstocking as well as the understocking. And if it is an understock situation, it's a very serious problem, obviously. And order quantity is dependent on the state of Markovia demand process and inventory level. Ability to do so may improve healthcare system efficiency and accuracy in ordering decisions. That means ultimately, you have to judge your performance must be judged with the effectiveness. What kind of results you get? Percentage reduction in cost, percentage reduction in cost of treatment, and other quantitative insights. Other quantitative insights is very important. What we have observed at the first level, you go for the exact system, because the exact solution you never know. Is it okay? Because it's basically a closed form solution we'll never get. Closed form solution, reasons are properly understood. So what you have to do, first an approximate solution, and then you check that what extent the approximate solution can solve your major problems and all. And so it is to be tested again. It's like the continuously you have to update your model, and certain point in time you have to stop. You say yes, majority of the problems you can handle with this model. So such the approach will be very, very helpful. In fact, the research extends uh, literature by developing dynamic inventory control systems for healthcare items. Relationship between demand and patient condition. We derive the transition probabilities. We have to collect data, in fact, and we use stochastic demand state and develop an MDP model to determine optimal state dependent. This is the application to physicians prescribing behavior-based healthcare inventory control systems. So just quickly, I will just go through again the same model, like the demand estimations you have to do. Physicians prescribing behavior, this is hidden actually. Patient condition based, type of care unit, patient length of stay, and the dose of medicines prescribed by physicians is very important. In fact, what is the level of complexities? So that also you have to judge. Any problem of this nature, when you try to model, you must know as a researcher what is the level of complexity. Is it okay? Although we know in the classification, when you go for the classification, starting with the most simple one and ending with the most complex one. And in majority of these problems which you come across in healthcare sectors, those are in the other extremes. That means very, very complex issues. Is it okay? So this is the problem setting for this one, and the sequential decision problem, stochastic system, finite horizon, periodic review, limited storage capacities, all these are there. So this is the complex systems you have, okay? So physician prescribing behavior, stain transition probability, quantity of medicines prescribed, emission probability of observation at each stage. And these are the formulation. Obviously, you have to use different notations and all for different parameters, variables. And okay, so controllable factors, uncontrollable factors. So the binary, these are the decision variables. Okay, so the
Professor Ray,
cumulative
Professor
decision.
Ray, am I
Yes,
disturbing you?
yeah, please. Time is
Yeah, yeah,
running
yeah,
out.
yeah, 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 yeah. It's a
Give me
fast
1 minute
approaching.
of time. I'll conclude. Okay,
Yes, please.
fine.
Thank you.
Okay then. So sorry because there are some
No, no, no.
disturbance.
It's very interesting, but
So
constraint behavior is there.
yeah. So this is the model formulation. Okay, and so all these details are here. In fact, if someone is interested, definitely I presume that definitely he or she should be in touch with me. We'll definitely discuss at the individual levels. Okay, all these details. In fact, okay. So what I'm trying to highlight on this session that many of these the problems right now your next generation, the young generation is facing these days, whether it's a service sector or manufacturing sector, any sector you name, they're all very, very complex in nature, and there must be proper integration. This has not been the case when we joined the industries in 80s and in 70s. Is it okay? So our problem was, those days was very, very simple. Whereas the young generation, most of the problems they face is very, very complex in nature. And as I've told you, like the COVID-19 situation, is it okay? We have taken up a project, like say the medicine supply chain, how it is disturbed by, the COVID-19. Is it okay? Pandemic, and how to make sure that how to make your system a robust one. You probably that, but fortunately, what you'll find in 1947, 1957, 1967, this way you get the data, and you try to measure the robustness of our healthcare system. You will find that that our system's robustness is very high level. In fact, is it right? So that is very important. In fact, and probably the country like the Japan is 100% almost industrial industries as concerned. This is 100% imported economy, import-based economy, and you will find that they're able to create a robust system. So that's our challenge, in fact. So the solution approach, these are all details are here, and again we have collected data from a multi-specialty hospital, in fact, and this is the model translation. So these details are here, in fact. So it's a PhD level research work. So the results and finding optimal inventory control policies, and then obviously go for verification and validation. And the validation, you are all aware of the different kinds of approaches depending on the type of problem you deal with. So these are the conclusions, in fact. So what sort of action you require when the stationary demand, non-stationary demand, and what is important is that you have to develop these cost curves and inventory control policies and the reduction in cost of treatment. So this question will be asked by the management. Okay, tell me what is the percent reduction in cost of treatment. It is my point. So there must be approach to answers. These are the references, in fact. These are very good references we'll find. And these are our publications on all this. Is it okay? Still we are working on it. And particularly at this point in time, we are working on the blood bank management systems, and what we have found that word-based tools and techniques are readily applicable. Okay, so thank you so much. And before I close, the quote Charles Darwin: "It is not the strongest of the species that survives, nor the most intelligent that survives. It is the one that is most adaptable to change." Charles Darwin. So if you have any questions or queries, okay. Right. Sorry, I couldn't.
No, it's fine. It's fine.
Properly, in fact, maybe the problem at our end. Okay. So, okay.
Okay, Professor Ray, I'm extremely happy to see you again, once again, I think. And you have made a very beautiful presentation on the healthcare system as a whole, addressing issues like reachability, affordability, quality, and cost. These are the very important issues that the healthcare system should provide. I'm also happy that you have taken up very nice case studies on inventory control problems, and particularly the application of dynamic programming and Markov chains.
So shall I make a comment? You know, Russell Accord.
Yeah. Okay.
Yeah, you know, at one point in time, he says he wrote an article paper that the future of operation research is past. That is the first article he wrote in the early 80s, because that is the risk, in fact, we have. And many a time, the problem is a genuine problem, practical problem, but then, unnecessarily, many a time, you go for mathematical modeling, knowing fully well that such complex issues cannot be mathematically defined. So, and the next paper he writes, that is the operation research revived. Is it all right?
Okay. Right.
That's right. So
no, I only wanted to say, having gone through all, ultimately, at a field level, if we can give decision rules for management, that will serve wonderfully well. Now, only one or two questions before I invite the next speaker. Okay. Just one for a courtesy. Audience, any questions?
So just one question. I'm Monisha here. I belong to Infosys. Just one question. 145 fifth rank out of 190 nations you mentioned. So it's quite alarming, actually, India's ranking in the healthcare. So just wanted to know, sir, is it last 1 or 2 years data, even after taking such of initiatives?
Let me tell you. One thing is, whenever you talk about ranking, is it okay? There cannot be any general conclusion. Are you getting my point? You are aware of, in fact, that how popular our, that medical tourism is. Is it okay? Our, suppose I'm telling you, if you go to the operation theater, what you'll find in our country, that this is totally manned by our own people. Is it okay? Our doctors. Whereas in the operation theater, you will find almost each and every item is imported, and their drawings are not known, the design is not known. Same thing, suppose I don't want to name other countries, in fact. If you go to other countries, I don't want to name them, you will find that the same level of operation theater, same, okay, but it is manned by the countries from where they have imported this technology or these processes. Are you getting my point? So what is the main advantage we have? The quality of our medical professional is excellent, and it is known throughout the world. So in that way, our inherent competency, that is fine. But the question is, sometimes, these issues is not highlighted. Obviously, for ranking, this is the primary issue, the quality of healthcare professional. That is number one. Right. Number two is how quickly, how many different types of treatments we can do. That is also excellent, in fact. Are you getting my point? Yes, our main problem is population and the population. Is it okay? But still,
fine.
That's what I'm telling you. So just trying to highlight, whenever you say the ranking behind the scenes with particular criteria, it's not only for healthcare systems ranking, for any ranking. Are you getting my point? So there are certain groups. That's very good.
Okay.
Yes, on inventory, on these aspects, definitely, because I have already pointed out, is import based. Almost all the medicines, they're import based, in fact. You're getting my point. So that's the main, in fact. But
Professor Ray, may I interrupt you?
Okay.
And may be permitted to interrupt you. The interested speaker viewers can always write to Professor Ray, and seek his advice. I thank profusely Professor Ray for spending his time and giving a wonderful lecture. Thank you once again, Professor Ray.
Thank you so much.
Now I take the I would like to take the opportunity of introducing the next eminent speaker for today morning session, Dr. R.N. Subudhi. Sir, he is available. I am able to see him. I would like to give a brief about the background about Professor Ravi Narayan Subudhi. Professor Subudhi is a senior professor of management and has got more than 32 years of experience. After completing master's and MPhil degrees in statistics, he completed his PhD in management with a senior fellowship from CSIR. He is also an alumnus of IIM Ahmedabad, where he has completed his FDPM. After serving Berhampur University at Odisha for 21 years, he served for a brief period at VIT University, and now currently he is at KIT University as a professor of management. Professor Subudhi has published 9 books and wrote about 70 research papers. He writes popular articles for regional newspapers regularly. He is the former editor of journals and magazines like Strategy, Suman, Disha. Presently, he is the chief editor of peer-reviewed management research journals, Parikalpana of KIT University, a peer-reviewed journal since last 10 years. Professor Subudhi is a well-known person in the area of entrepreneurship development and management. I'd gone through the publications list, and I briefly ascertained that he is apart from being a statistician, he is a well-known man in the area of entrepreneurship development, small business management, and he is also into marketing, and more so in the current context, he is into the area of digital marketing. So these are the various contributions of Professor Subudhi. And today, I understand he is going to speak on stock markets, stock market operation efficiency and research. So that's an area, although I'm not too much aware of stock markets, but still most of it is OR modeling. So I also am very much interested in listening to him very much. So I invite Professor Ravi Narayan Subudhi to take over and make his presentation to us. Thank you, sir.
Thank you so much. Am I audible?
Yeah, you are very much.
Just kindly help me if my screen is visible.
Yeah, it's going on, fine.
So,
slides are there, screen is there. Okay, no problems.
Thank you so much.
Fine,
At the outset, I must pay my deepest respect, regard, and love to the legend, Prof.C.R.RAO, for which we have been organizing such academic meet like this. And also my respect, gratitude to my elder brother, Professor PROF.C.R.RAO ji, for giving me a chance to participate in this memorable event. And this is something which should be really very, very important and memorable, and it will be recorded in history. I must actually salute to the spirit of Professor Rajsekhar Reddy Garu for his untiring effort for uniting all statisticians, all researchers of OR, and conducting events like this regularly. Today, I was traveling in the morning. I have come to the temple city of Puri. I think I am addressing from temple city of Lord Jagannath Puri to the organizer of temple city of Tirupati, and we are connected by His Holiness the gods. I have come with my family to Lord Jagannath Puri. I'm speaking. I taken the permission from Professor Rajsekhar Reddy Garu that I'll be speaking only 30 minutes. I have deliberately taken a topic like a new for OR scholars, statistics scholars, because I have been teaching stat and OR for management students, and I have been trying to apply the theory of OR and stat and whatever possible in the application area, application research. So today I thought I should take up a newer topic. It's not totally new to everybody, but I guess like some of our hardcore mathematicians, statisticians, or scientists, and maybe like something relatively new. And here is a market, here is a business where every day thousands of crores of rupees is being traded, at least in India. And when you are taking all global markets, it's billions of dollars every day being transacted. So today I'll be just touching upon the basic concepts of stock market operation, and I'll be just again towards the end, I'll be suggesting how it is being traded, the technicality, and also the research what the scholars have been doing on this particular area. I would request Chair Sir, kindly help me if my screen is not visible, if I'm not audible. Please kindly help. So to be very brief, we are going to discuss something about stock or share market. To me, to be very brief, I'll be just taking share and stock to be synonym, though they have got like slight differences. And it is something like organized trading of equity shares of different companies, government as well as private. And this is done through established stock markets of every country, and huge amount of money being transacted, and government and tax officials also got margin as tax percentage what they got. And moving ahead, as we can briefly define, share is the smallest unit which could be issued by a company at the time of raising fund, and we will be discussing later, this is called primary market. And the smallest unit ownership is bought or sold through an exchange. This is referred to as the share trading. And stocks are the set of shares a person will be having, which is given by the company, and the person can trade it, sell it, buy it in the stock market. As briefly we can like discuss here, I was trying to suggest initially it is being given by the companies, which is called primary market. And once it is subsequently traded, it is called secondary market. And this is being done in stock exchanges. That could be also pre-market, but we are here. What happens in stock market, how it is like traded, and what kind of research interest scholars have. So here we'll be discussing here. Now, very briefly, primary market, what we have just suggested, company issues first, and the investors, general public investor, they will be getting the shares. Once they are the owner of the share, they can legally sell it, trade it in stock exchanges. And once you are owner of your primary shares, you can sell it in secondary market, which we'll be calling at stock exchanges. Now, for statistical analysis, I'll be just suggesting here there is immense opportunities. It is a virgin area till date, I can say. Lot of war analysts, statistical analysts can think of getting employment in this sector, a sector where billions of shares traded worth trillions of rupees every day. I'll be just briefly suggesting a last year data of our own exchanges. We have got top two exchanges called Bombay Stock Exchange and National Stock Exchange. I'm just giving some like facts what I had collected last year. As you can see in Bombay Stock Exchange, there are as many as 11,000 plus different company shares, and these are the trades and these are the total turnover that day, particular day, over 8,700 crore rupees worth share traded. When you talk to National Stock Exchange, NSE, it is also taking over, and it is also leading from the front. And similarly, you can say like how many quantity and what is the turnover, how much of traded happens every day. I'm just like just suggesting, so like huge sector, but lot of trading happens every day. Now, I would request the viewers to please see from right to left, not left to right, how the index, it has moved since last 20 years. I have taken from 2000 to 2019. As you can see, except 2 years, that is like those who have got investment in stock market, they must be knowing there are some like scam period, person meta, Ketanpari kind of thing, and raised, it is increasing steadily. So this is what like just to say that in the long run, it's a profitable business. This is a verification. It testifies that. Okay, moving forward, there are some like statistical data. I will be sharing this PPT for the scholar if at all they will be interested. How the open price, high price, low price, and close price is there. And as we seen in the last slide, 2 years it was like a setback, crisis, or scam period. Other than that, it was a smooth selling kind of thing. Moving forward, let's very briefly talk about the evolution of stock markets. It's a pretty old business. It started as late as 1494 in Amsterdam, and in India, it started in Mumbai in 1875 first. It was then known as Native Shareholders Association, and thereafter it was regulated by government, and we had formal stock exchanges at Ahmedabad, Calcutta, Madras, much before the independence. Now, very recently, those who have been trading in the stock market, they must be knowing there are many regulators and regulations. It is more streamlined nowadays. And if anybody is having grievance, one can approach to SEBI, and we have got acts as Securities Contract Act 1956 and Indian Companies Act 1956, and the more important is SEBI Act 1992. And the general investor can approach SEBI office by here. Okay, I'll be just introducing few concepts called bullish market and bearish market. These are the few terms investors know. If market is upbeat, it is upward moving, or if you are optimistic, we call it bull market. And if it is in a downward phase or pessimistic sentiment, we call it bear market or bearish trend. These are the two concepts. It is understood well by all investors and researchers as well. Now, I think this I'll be skipping. These are the procedure how a company is listed in stock exchanges, and that is like a compulsory that every company, if it is to be traded, must be listed, regulated in stock exchanges, so that public can trade freely. Let me tell you, one smallest equity share, the face value could be 5 rupees or 10 rupees, but it is traded higher as it appreciates over time period. And this is done in secondary market trading. And those who may be knowing the primary market, once it is given first time by the company, is called IPO, initial public offering. Now these are the top 10 largest markets of the world. As you can see, US, Japan, UK, China, Hong Kong, they are ahead of us. But in India, Bombay Stock Exchange and National Stock Exchange are doing really great job. And very recently, since last few years, NSE is really taking the lead. So Bombay Stock Exchange is the oldest one. And we also have regional stock exchanges, but these regional stock exchanges are gradually having less relevance because it is online trading. So people prefer doing it in NSE or BSE or both. Now, how to know how the market is moving? So to know that, every day we compute some indices both for Bombay Stock Exchange and National Stock Exchange. we have the most favorite index called Sensex, which stands for Sensitive Index, and it is based on top 30 shares. And we also have got small cap index, mid cap index, and we have got different variety of indices to know the mood of the market. Similarly, for National Stock Exchange, which is more broad-based, the most popular index is called Nifty. Nifty stands for NSE 50 Share Index, and it is calculated, monitored by S&P Price Shield, and this is called S&P Price Shield NSE Index 50. We also have broad-based index for 100 top 100, index for top 500 shares also, but most popular are Sensex and Nifty. Moving forward, before we try to understand how it is traded, let's very quickly take few important words. I think many of us know about the stock, securities, share, which we briefly narrated just now. And one of the other feature could be like a company can issue debentures. These debentures can be in different forms. One could be convertible debenture or insert CD. Another could be non-convertible debenture or NCD, or one could be partially or fully convertible debenture. These are like debentures issued by something like a fixed deposit. And in market, financial market, we also have mutual funds, and we just differentiate between the primary market and secondary market. Now, as we may be knowing, people invest in stock market not only for price appreciation of their shares, they also get regularly every year bonus or dividend. Now, let me introduce how it is traded. It is actually traded through brokers and sub-brokers or agents. Okay. Now, when it is online trading, let's see how it is done. Very recently, since 5-10 years, we have moved to paperless mode, which we call dematerialization or demat form. In short, demat form, or in full, we call it dematerialization. For trading, you need to have demat account for buying or selling. Now let's see how it really happened. I'm pretty sure Professor Rajsekhar Garu must be having some shares. Earlier, decades back, we used to get paper-based certificates. It looked like this. As you can see, I have, for example, shown you the front side of a equity certificate where somebody had bought from the primary market for the first time. And this is called paper-based. Once he or she owns, he or she can sell in stock market. That is called secondary market. Now, if it is sold, please see on the reverse of the certificate, a new buyer's name comes. This is my wife's name. I was like having this certificate, and when it was traded, it is manually done. It's a very painful process. Somebody does it, and it is sent by post. It comes by register code to you. So it takes a lot of time. It could be like damaged, lost, and in online trading, and it is not there. Now the trading is mostly done by NSE or BSE, and we can show it how it is being done. Today Saturday is off, so these are the websites, and those agents, when you want to do it online, you have to go through one of the agents. So most popular agents or brokers are kotaksecurities.com, ICICIdirect.com, Parvi, or Safan.com. There are so many others also there. Now let me tell you about the role importance of depository participants. As we just suggested, there is no paperwork, no equity certificate will come. So where it goes, when I buy, that electronic form will be deposited in DP. There are like central government controlled depository participants like NSTL, SHIEL, where all shares will be kept. Okay, so if I am buying, my shares will be deposited somewhere in DP. Okay. Now moving forward, let's see how it happens. Suppose there is a transaction which could be a purchase or a sale, and there is one investor, and there will be online broking service provider like Kotak Securities, Kavi, and you have to route through them. Now here is the DP or the stock exchange where it is actual trading takes place, and then the transfer happens. Transfer means suppose I'm buying, I have to pay money and get certificate. Okay, and it is called D2 within 2 days. Once I pay money, then I get back the share and it is deposited in DP. When I'm selling it, I'm transferring my share from DP to the buyer and I get back money to my account. It is done automatically. No physical transaction happens. So I'm transferring my equity share and I'm getting my money to my online bank account. So this is where the role of depository participant or DP comes. Now let's take a look how the bullish bearish market happens. Suppose it is something like a hypothetical I have given. Index means some average price. Suppose you could guess, you could estimate by some statistical analysis that it is going to increase. Then you can advise a potential investor. One can buy at this stage. Please look at the screen. And same day, one can square it off or sell it without paying anything, without retaining the share. You can square off and you can make money here. Suppose there is the reverse thing. Those who are smarter, if by chance you could predict concretely, clearly that it is going to crash or it is going to decrease, what you can do, suppose you do not have anything, still though you are legally allowed, say you can sell at this point, initially at the beginning of the day, and you buy back here at a lower rate. So it is squared up, you are not transferring any share, but you are in a position to book profit. Now, but if something happens like this, I'm just like now giving you the picture of one exact day. So what I had 3 years back, this data, suppose it is more of a flat. It is not a smooth increase or decrease, and you cannot take a position. Suppose you have sold here and you don't have money. What you can do, you can buy back and the difference you have to bear yourself. So this is something like a risk-taking kind of thing. But if your prediction is better, then you can perhaps advise your potential investor to gain money. And now the role of statisticians come. How do we make prediction? And I'll be showing you back. Here is a simple graph, and here is a candlestick graph, where you are not only reflecting the mood of the market, you are also showing the height of the candle, so the volume of this share traded here. So here is a less, here is a high, that many shares are traded here, right? Now, say for example, I'm showing you January to March, 1 quarter here. So if this happens, can you take a position? Suppose you had purchased something here and you want to move the profit here. So now the role of statistician is, if you can study market carefully, are you in a position to make a correct prediction? Is it going to increase or is it going to fall? That is what your knowledge is wanted by the investors. This is what we have to do it. Now, on this, like say trend line analysis, you can do or something else. But if something happens this, how do you do? Should we make a prediction like this? Or should we make a prediction like this, which is something pessimistic? Or we take a holistic thing and you ask your investor to buy and hold. not to panic, not to sell in between, but in the long term, one can realize the profit. So you can advise that way. Moving forward, I'll be just showing the latest news, what happened during the COVID actually. As those who might be watchful towards the changes happening in the stock market, as COVID effect unfolded in March, you can see a huge crash happened. A lot of investors really got panicked. What is going to happen? And there was a prediction that COVID is going to continue for 6 months, 1 year, and many people lost money here. So mid of March, there was sharp fall here, and but the market survived, and it looked up, and it is really moving. So this is what I'm showing for this 2020. It's almost 1 year kind of thing. But if you look to a closure last 6 months, suppose say after March, after that crisis, you can see that this is for the last 6 months. First graph, it is moving up, and this is just yesterday. This is for you can see how it is coming up. So what I will be suggesting, though it appears to be quite fascinating and attractive for a common man, but it is really quite challenging for statistical analysts. The main is how to measure the mood of the market, how to predict what is going to happen in short future, what is going to happen in long future, and what is your advice prescription for huge investor, which we call HNI, high net worth individuals, those who really invest in lakhs or crores of rupees every week, every month. There are very rich families, those who invest in crores. So if they are hiring you as a consultant, what would be your prescription suggestion? Can you really measure the mood of the market? That is the challenge for statistical analyst. I think this I'll be skipping. I suggested about some scam which happened during 2008 and later there. Let's not focus on this. But what we all scholars should suggest that what is the research potential for statisticians there in stock market. It starts from simple descriptive analysis, which could be like taken to numerical analysis, and then further some bit higher in-depth analysis like risk analysis. Say you have selected 10 companies share, which is high risk share, so that one, suppose a investor is a risk taker. Risk is related to gain, high risk, high gain. But some investor would be not interested to take high risk. If one investor is not interested, averse to take risk, then you can advise some script which is raise risky. So you can categorize the companies into three categories: low risk, medium risk, and high risk. Naturally, high risk can have a higher chance, higher probability of increasing much, much faster. I'll be showing you that it could be much faster than real estate profit. It could be much higher than old investment profit, and it is something like the highest in if you selected shares very, very carefully. Now, one of the research interests by scholars is like to relate the volume versus the price, and this will be very easy. Mostly it could be like, but we need to go beyond that. And one of the most research thing is if you get some insider news, it could really drive the volume, and this insider news may fade gradually, which could reverse within 4-5 days or 1 week. So if you happen to get access to some insider news, and if you can capitalize and take position within first 3-4 days, then you can really make more profit. Okay. And moving forward, um, volume rise would be really a good indicator to take your position that a script is in demand. Now, there is another area of research which is called EMH, that is called efficient market hypothesis. This is basically one hypothesis which is tested if information has the key influencing factor to change or increase the prices of a share. So there is a lot of research happening on EMH area and lot of statistics being used. I'll be showing you some path-breaking work which has been done by professors. This is basically for predicting the future price of equity share. Now, EMH was first introduced by a French mathematician in 1900, and his thesis was theory of speculation, then by Paul Samuelson in 1960. And efficient capital market. This article by Pharma was actually one of the epoch-making article. As you can see, this single article has citation over 19,000 last year. It could have really crossed 20,000. I have not checked today. From the citation, those who are senior professors attending this session, they must be aware that how important this area is. A single article, not the author, this particular article has been cited for over 19,000. I'm just putting this record, Google citation of last year. Now, next, by another article by same person, Pharma, which was published in Journal of Financial Economics in 1998, is also more than 6,000 till today. Okay, this 5,100 the record which I had collected last year, and of course the professors can know if an article is published earlier. It is 1970. Naturally, it will be more cited, and chance of it is published later. So that's why it is like less. But this my purpose of telling this particular area that there's a much in demand and it's a well-researched topic where statisticians or the scholars who are statistics can do real wonders. And another by Granger in Journal of Forecasting. It's a very relatively recent one, 2004. And I was checking here, this is a figure of last year, and then this year it has crossed 500 plus. So just like showing that how interesting, how important actually this field would be if we really take the research or ask or direct our scholars to devote some time in applied research in stock market. So again, to senior professors like me or Professor PROF.C.R.RAO, we can also suggest teachers to use this topic as a simulation model in our class. And I have been doing it for my MBA student project work. And stock market operation could be really very, very interesting, where students understand the nitty-gritty of stock market operations. And I would be really stopping here. If any question, I would love to respond.
Before I request the audience to make a question or so, first of all, I would like to thank Dr. R.N. Subodhi for wonderfully presenting what actually is a stock market, and then what is meant by efficient stock market. The modeling for efficient stock market and simulation. Simulation and modeling actually is a beautiful learning experience. You can model it, simulate, experiment, then learn. So this is a wonderful way of learning for people without losing money. That's very important. So for people like me, that's going to be wonderful, but I'm past 68, so no more experimentation with that. With money.
But you look very young.
but for youngsters, the simulation happens to be a very beautiful tool for experimentation. If mathematics, complex mathematics, like earlier paper we have seen, we need not go through all that if for some cases. And for this, simulation is going to be a wonderful tool. And I'm very happy that I remember, sir, I remember that, I don't know about that pharma article. I remember to have read one article by Ekpan and Pharma, dynamic cash balances. I was doing my research at IIT Kharagpur way back in 81. And I was trying to do work on working capital management through inventory, etc. At that time, that famous article by Ekpan and Pharma, I read that article. So I remember that the moment you said pharma, so I thought is the same pharma. It could be different, but is the same. So I'm very happy. This is another model. I knew about something about Harrow Markovitch or the capital asset pricing models, etc., etc. This one, efficient market operation, etc., are through information, right? Modeling through information and then trying to find out the value of a share. Because I was not in that area, is not known to me, but I'm very happy that you have exposed me to a new area, perhaps to the audience also. I'm extremely thankful to you, sir, for lucid manner, not nothing complicated, very like a management man makes people understand us. So in a very lucid manner, you have explained to us the whole issues regarding capital markets. Now before I conclude, I request the audience to make the best use of the expert award. Thank you. Any queries?
Actually, today I'm operating from my sister's government quarter from Puri. I have come from Bhubaneswar to Puri. I will be having darshan.
Nice,
So
very nice.
when my elder brother Professor Rajasekhar Garu asked me, so I cannot say no. So I requested my relations to give me 1 hour, 1 room. So I'm operating from my sister's government quarter from Puri.
Very nice.
Very nice, sir. Thank you. If
thank
there
you.
are no
Thank
queries,
you so much.
and
Namaskar from. Thank you, sir.
Thank you, Subhudev, for your nice informative lecture. And on behalf of, I'm very happy that at least so we have some representation from Bhubaneswar chapter, because when I was the president for War Society of India, so the chapter now this and Aligarh and Meerut, all these 3 chapters came up. So I'm very happy. So Bhubaneswar chapter is very active under your leadership. Now I know Srikanth and you are doing excellent job. So thank you. So we'll invite you from sometime to Tirupati. So thank you.
Thank you so
I'll
much.
also make an opportunity. We'll invite both Professor Ray is there. He's still there, Professor Ray. Are you there? I'm seeing you.
Thank you, sir. Thank you. Bye-bye.
Bye.
Yeah.
Professor Ray, you are still there? Okay.
Yeah, he is still there.
Still there. Professor Ray.
Yeah, he is there.
He's there. Okay. All right. Muted. He's muted. Okay. Now, anyway, I thank Professor Rajasekhar Garu for. I know him since long time. Since he's my erstwhile colleague, we were there since 40 years. We know almost every day. We stayed in the same quarters here and there. Very neighbors also. He is very dynamic, and he pushed the War Society in Tirupati to a great extent. And I congratulate him not only for the personal development but pushing the war theme throughout the country. So I once again congratulate and thank him for the wonderful drive he has got, even at this age.
Thank you, Professor.
Now, I would like to conclude this session, and I thank him once again for giving me the opportunity for meeting my old friend and the rest of the people. Thank you.
Thank you, Ramakrishna Rao Garu, for sharing the session. And I wish to inform you that right from the inception of starting the War at the Tirupati chapter, Ramakrishna Rao Garu and other people, they're all associating with us, with me. And we have done every time, whenever suppose we wish to organize, we will meet and discuss some issues. So this time also I requested Ramakrishna Rao Garu, so he suggested, yeah,
Somehow your
MTech in PhD in Kharagpur IIT. So
yeah.
yeah, he accepted my invitation and he has joined the session. So thank you, Professor
Thank you.
Ramkrishna.
Thank
So we will meet by 2 o'clock afternoon session. Professor Ganesh, Dr. Ganesh from NIT. So he is going to chair the session, and another we'll have 4 lectures today afternoon. And there is Pankaj Gupta also may join in the third lecture. Okay, thank you.
Thank you. Thank you so much.
Thank you, Professor